objective of this conference. In support of Saudi Arabia's aim to reach net zero emission by 2060, the International Society of Automation, Saudi Arabia section, takes into its role to promote the enabling automation and digital solutions to achieve this objective. Saudi Arabia, being the largest provider of energy and as well as hosting many diversified fields, has a very important goal, which is to reduce the emissions while maintaining and keeping with the world's continuing demand for energy. It is one of the biggest challenges requiring major technological breakthroughs. Digitalization is seen to be the enabler for a decarbonized world. We are here bringing people together, leading experts and organizers and organizations from around the world and from multiple sectors to showcase technology and innovation, in addition to a thought leadership to provide a better understanding of the way forward for industries to reach net zero emissions by 2060, and investigating the role of digitization in achieving this goal. The 2 days were covering topics including automation systems, communication systems, artificial intelligence, 4IR, and data analytics, in addition to sustainability. So for further information, kindly visit our website, which is a very simple website. It's just dtnetzero.com. Thank you, everyone.
Assalamu alaikum. Honorable guests, good morning. On behalf of the organizing committee, I would like to welcome you again on the second day of our lovely conference. Before we get started, I would like to highlight, in case of emergency, that the exit doors are located at the back and to the sides of this room. Ladies and gentlemen, yesterday we have dived into the importance of pursuing digitalization toward net zero emission. Our distinguished honorable guest speakers have delivered us and conveyed how we can accomplish that. And today, we're continuing our journey with another handful exciting topics presented by leading people. Starting with the first topic for today, which is about digitalization is the true enabler towards zero net emission, presented by Mr. Salman Al-Yami, the Process Network and System Superintendent at Sadara Chemical Company. Please help me to welcome Mr. Salman Al-Yami.
Assalamu alaikum. Good morning, ladies and gentlemen, and welcome back for the second day of digitalization toward net zero emission. And I would like in the beginning to thank the committee and the supporter, sponsors, and as well the key speakers and the attendees for making this successful conference. So I'm not going to add more to what have been said in the past. I mean, in yesterday presentations, majority of the people, they have touched what is the statement of zero emission and what's the issue with the global warming. So allow me to start with, which one is this? Okay, thank you. So basically, we all know what we are facing today and what are the targets for the world to reduce the emission and help the environment, help the safety by participating in reducing the global warming. And I think there is a vision has been set from all countries around the world to drive the zero emissions. How we go, I mean, the statement is mentioned there, and how we are going to move to the modern digitalizations and toward the zero emission. The digitalization becoming a true enabler and a key factor for enabling the organizations, enabling countries to move and accelerate and stabilize and optimize. It's all about optimization. How we are moving from the current status now into a zero emission without changing the infrastructure. I mean, changing the infrastructure is going to be too much costly into organization to invest in. And what will be the best way to move forward with an efficient way of driving the zero emission. So digitalization is one of the key enablers. It's accelerate, it's optimizing, and move the resilience of organization toward the zero emission. We see here the modern decarbonization digital energy systems, where it's driving to resilience, tolerating customers, the whole system optimization, which all what we do is about optimizing our emissions, accelerate the decarbonization by implementing the digitalization. Here in IR 4.0 now, the industrial revolution will help us. I'm mentioning some examples. It's not all what we have as a technology, but are some examples like the 5G, IoT, artificial intelligence, data mining, or big data analysis. So here we are moving, instead of moving and changing the whole infrastructure, we are not there yet. We are not a new or a green field that we move to a green industry from the beginning. I mean, there are many organizations that's very old organization, and to adapt and to move to a green energy, we have to change our infrastructure. So this will help us all in the industry or in the world to move into a green and helping our environment. So since this started, Saudi Arabia has been a leading energy producer around the world, and Saudi Arabia have committed to support the effort and fight against the climate. It's been the heart of 2030 vision, and it's a vision for 2060, as long as for the whole world. So how we are going to reach there is by digital technologies. I'm mentioning here some examples of digital technologies that we can adapt and we can move. It's being used around the world. And I'm mentioning about the RPA, automation, artificial intelligence, 5G, and drones and robotics. RPA is moving a green business. How to move from digitization to digitalization, then becoming a green business. AI for processing large data, predict and take a decision. 5G, as you know, the 5G helping to process a large data that we are having right now. Now, every business has a lot of data, have a huge data that's not been analyzed, not been processed. It's a new oil. I mean, the data that we have, if we analyze it, if we come up, it will help a lot in making the decision by processing in the right way. So 5G will help everybody in processing large data. Drones and robotics, this will help in moving into for the maintaining efficiency, safety, and reliability can be used. And I can share an example that we have used it within Sadara. We have used the drones for inspections and for the confined spaces without people going into a risk. We reduce the risk. We reduce the intervention by people doing this activity by using the drones. Additional to this technology, IoT, and I can mention here is Repsol and Saudi Aramco have committed, teamed together to build one of the largest zero emission facility to produce fuel using the IoT. It's full of used IoT solutions to make it a zero emission facility. Blockchain with packaging, with logistics, that will help a lot by implementing the blockchain. Virtual reality and augmented reality. Sorry. So virtual reality and augmented reality, the big data and analytics. Big data is, as I said in the beginning, it's our new oil. If we use it right, if we analyze it right, it will help the organization to act and to take a decision to help the net zero emission. Here is a summary for what we have. This is my last slide, and whatever we say here in the conference, either my peers who did the presentation and yesterday and today as well, it will be an essential to keep increasing, decarbonizing, decentralized energy system running in a stable and affordable way. Digitalization will have a steering role as we move toward net carbon zero emissions. So fast movers who will gain, or fast mover who is going to adapt the digitalization will enable them to gain the experience and as well to have the chance to establish themselves. So this is my last slide, and thank you.
Thank you, Mr. Salman, for such a wonderful presentation. Our next speaker, Dr. Mohammed Asif, a professor at King Fahd University, who's going to talk about the dynamics of net zero energy transition. Dr. Mohammed, the podium is yours.
Okay, Assalamu alaikum and good morning, ladies and gentlemen. It's truly a privilege to be part of this esteemed conference, and given the fact that it is, I believe, one of the pioneering events on this very topic, as Saudi Arabia has recently pledged to 2060 carbon neutrality targets. And yesterday, we have seen very exciting overview of technologies and projects contributing towards zero carbon, and I hope to see more exciting developments today. However, it is equally important to address the topic of zero carbon holistically in a comprehensive manner. Yes, technologies are going to be pivotal in the energy transition and towards carbon neutrality. However, technologies can take you only thus far if they are not supported by policies. And we have seen policies helping even average technologies succeeding in the market, and policy interventions have made absolutely wonderful technologies struggle in the market. So the technologies and the policies, they have a very dynamic and very integrated relationship, and that's what we need to look into. And in my talk, which is Dynamics of the Net Zero Energy Transition, I shall be looking into the topic of energy transition in terms of its main drivers, technology features, challenges, prospects, and the way forward. And in doing so, the main strands of my talk will be the concepts and drivers of energy transition, the dimensions of this energy transition, what are the prospects, what are the challenges, and I will conclude with some concluding remarks. So energy transition, what's the concept of this unfolding energy transition? The United Nations, in the wake of Paris Agreement, wants the world to shift away from fossil fuels towards cleaner energy sources by the middle of this century. This is the fundamental essence of the zero carbon energy transition. However, this is not the first time we are talking about energy transition. In the recent history, we have seen energy transition in the 18th century when the world shifted from biomass, which had been serving the humanity for thousands of years, to coal, thanks to the Industrial Revolution and the invention of the steam engine. And then in the 20th century, the world shifted from coal initially to oil and then to natural gas, which we are still benefiting from. And now the 21st century energy transition, which we are witnessing, which we are going through, is much more vibrant and diverse than the earlier two energy transition in terms of the technologies, in terms of policies, and in terms of its impact to us individually as well as holistically as societies and nations and the global community. So what are the drivers of this energy transition? The most importantly, climate change. And then rapid growth in the demand for energy, depleting conventional fossil fuel reserves, fluctuating and rather increasing energy prices, and energy deprivation. Let's have a look at this closely. Climate change. In 2017, a survey was conducted with 50 Nobel laureates as what's the biggest challenge the mankind faces. And they were given a range of options. And overwhelmingly, they chose climate change above wars, above poverty, hunger, disease, terrorism, you name it. And if we talk about, for example, Noam Chomsky or the late Stephen Hawking, they were not from environmental sciences, they were not from renewable energy or sustainability, but even they ended up calling climate change as the biggest threat facing the mankind and the planet. What it is leading to? It is leading to melting of the glaciers, the ice caps, sea level rising, and hence triggering weather-driven climatic disasters like storms and flooding and hurricanes, and then wildfires, which is a new phenomena in many countries, yes, in parts of Australia and North America. But I was in London in August, and the parks, public parks in London, they were fuming with the forest fire, which was unbelievable. We could not imagine this kind of situation. And then drought. Only 2% of the water we have is consumable. And even these freshwater lakes, they are fast evaporating in Africa, in Latin America, in Central Asia, in larger Asia, and many have said the wars in this century will be on water. And then food crisis, which is also linked to climate change. And let me share some anecdotal experience with you, very recent. I was in UK in the summer, and I spent 2 months in some playing grounds, and that was the scene in June. And by the end of July, this was the situation. This is the grounds had turned out, which was unbelievable. I've been there for 20 years and never have seen anything closer. You see the comparison, the stark comparison, and they say this is the worst drought Europe is experiencing in the last 500 years. This is going on, and we know what's happening in California and Los Angeles for the last many, many decades. Now, the second biggest challenge is growth in energy demand. In the first half of this century, the global energy demand is going to be more than double, and most of it is going to come from developing countries. And we need sustainable ways to generate this extra amount of energy that is needed. And then energy prices. This figure is before the Russia-Ukraine war, and the gas prices had increased by 500%. And we know that as the world is coming out of COVID, the prices of all fuels, whether it is coal, oil, or gas, increased. But now after the Russia-Ukraine war, the price jump is more than 800% compared to a couple of years ago. And we don't know where it is going to be ending up. And in UK, if I ask you, what do you think of UK? Is it a poor country? Is it a developing country? No. It is one of the leading technical economic powers in the world. And in UK this summer, 50% of the households will be fuel poor, which means they cannot afford thermal comfort. They cannot afford the bills. This is the situation in Europe. And then energy deprivation. We are in a privileged society. We cannot, probably many of us have never seen what is a blackout, what is load shedding. But as of today, 20th of October 2022, more than 1 billion people in the world do not have access to electricity. And even many of those who have access to electricity, it is not really sustainable. They are getting for few hours, and even it is low voltages and all sorts of issues and challenges. And when it comes to clean cooking and heating fuels, about 3 billion people in the world as of today, they do not have access to clean cooking fuels. This is a very real reality that we are facing. Now, in this context and background, we are talking about energy transition. So to me, this energy transition, which we conveniently call zero carbon or sustainable energy transition, it has 4 main dimensions. The first one is decarbonization. The second one is distributed or decentralized generation. The third one, which is the very topic of this conference, digitalization. And the fourth one is energy efficiency, which I, for the sake of having another D, called decreasing use of energy. So I'll take you through these briefly. Decarbonization. Decarbonization is being targeted through renewables, most famously, then hydrogen and fuel cells, electric mobility, decarbonization in the fossil fuel sector itself through carbon capture and storage, for example, and then phasing down or phasing out of fossil fuels. And finally, nuclear fusion. Renewables, we know the 6 main types of renewables: solar, wind, hydro, biomass, geothermal, and wave and tidal. Now, they are wonderful. These renewable technologies, they offer us many competitive benefits compared to conventional energy sources. First of all, for example, they have infinite resources. So the sun is there for last 5 billion years and will continue for another 5 billion years. And it is what leads to wind power, it is what leads to hydropower. So we are not short of resources. And then these resources are widely distributed. Hardly there will be any country in the world which does not have one or the other form of renewables in their backyard. I was in Scotland, and it is one of the best placed site in the world for when it comes to wind and wave and tidal, but there is nothing in terms of solar energy. Sometimes for 2 weeks we don't see sun at all. And here in Saudi Arabia, we may not have a lot of wind in most of the country, but look at the availability of sun. It's wonderful. It's absolutely brilliant. And then these renewable technologies, they do not produce any emissions, at least during their operational phase. So they are tagged to be environmentally clean. And then they have declining cost trend, unlike the conventional energy resources. We see the fossil fuel prices going up. And in last 10 years, the prices of wind power, solar thermal, solar PV, they have seen a steep decline. And then the sort of technological advancement that you see in renewables, they are unmatching. No other energy sector can match the sort of evolution we are seeing in the renewable sector. However, they have challenges. Intermittency, they are weather dependent. Sun is not there around the clock, and even wind, it is cyclic. You have 1 or 2 weeks of excellent wind, and then there will be days and weeks which is absolutely quiet. So you need storage, or you need diversity, different kind of resources to balance each other out. And then the renewables, they do not have any much running costs, but they are capital intensive, very expensive to develop. So this is a challenge, especially for developing economies. However, renewables is exploring new horizons. One of the, besides intermittency, the second biggest challenge renewable face is low power density. You need large land area. But now we are going to seas, which is giving us much better performance. And you have floated PV, which is giving not only better performance, but is also resolving the issue of low power density. And we see concentrated PV systems giving us 45% efficiency, more than 45 actually. We see bifacial PV. We see concentrated solar. So the advancements are phenomenal in the field of renewables. And then when we look at the wind power, imagine the scale up. They have already produced 15 megawatt wind turbine, and 20 megawatt wind turbine is ready on the drawing board, and the wind industry is targeting it for 2025 to 2030. One single wind turbine producing 20 megawatt and powering millions of homes. Yes, that's what we are experiencing. And then one of the biggest success stories in the energy sector is batteries. 10 years ago, if we're talking about batteries, nobody would give it a serious note because it's only kilowatt technology. But thanks to Tesla's 100 megawatt project in 2017, now we are seeing gigawatt scale battery projects. And there are already 300, 400 megawatt battery projects in operation. And in USA, they are working on a 2.5 gigawatt project. And in last 10 years, thanks to these advancements, wind power has seen a 10-fold increment in capacity, and solar PV has seen a 20-fold increment, actually 40-fold increment in capacity. Hydrogen and fuel cells, they are also coming slow and steady. They have got challenges. We were informed about it yesterday. And nuclear fusion. China recently produced what they call it a sun. They have captured the solar fusion process for more than 1 minute, creating temperature in the range of 60 million Kelvin. And if it works out, it will be truly what we call game changer, because the fuel is free. Hydrogen is the most abundant element in nature. And then EVs. EVs have taken the mobility sector by storm. But if we are producing electricity from coal and oil, and we are only deceiving ourselves. EV will serve if it is coming from renewables. Otherwise, you are shifting just the emissions from one point to another point. And amazing development in the field of EVs. Now, public charging points are available everywhere. And even now, electric vehicles companies are coming up with, you go to certain points, and like you fill the petrol or gas, you change the battery. And now, finally, next is decentralized generation, which offers you flexibility, which offers you security, which offers you economy, which offers you robustness. And in the wake of renewables, there is no choice but to go for distributed generation systems. And finally, digitalization. We are living in an age of sensors, smart grid, and smart meters. They are already mature, technically, economically viable technologies. Now we are getting into large-scale data sets, data analytics, cloud computing. Then we need to dive into machine learning and AI to deal with these massive data sets and to see the trends and to make best use of them. Then there's robotics and automation. Then there's blockchain. And finally, one of the most lucrative stuff for certain elements, rogue elements in our society, is hacking. And this is a serious threat, and so we need robust cybersecurity. So these are the key dimensions of digitalization. And finally, energy efficiency. I have kept it deliberately at the end, not that it is least important, but it is the most important. I've been dealing with renewable energy and energy management for the last 20 years. I've been teaching about it, I've been doing research, I've been doing consultancy, industrial advisory, policy advisory. They are both same to me, but if you ask me, the best solution way forward to our challenges, to our problems, growing energy demand, is no form of energy generation, whether it is solar, wind, hydrogen, blue, green, you name it. The best solution is you save energy. They call it negawatt. Negawatt is the watt that you did not use. So that's the way forward. And for that reason, energy efficiency is absolutely cornerstone of energy policy frameworks anywhere in the world. Now, are there any challenges to the zero carbon energy transition? Yes, the set of challenges, because every nation has its own dynamic situation. The road to zero carbon, the way it is working in UK or USA, it may not work in Saudi Arabia or Japan or Korea or China, because every country has its own sets of opportunities and challenges and socioeconomic and cultural and technological dynamics. However, there are some general challenges which we can see in terms of developing countries. Obviously, the technology, not all forms of technologies have seen the technical and economic maturity. Loads of technical challenges remain which need to be worked out. Investment, it's not easy. We have tens of thousands of trillions of dollars of worth of energy infrastructure which needs to be revamped, and it needs hundreds of trillions of dollars of investment by the middle of this century. It is huge investment challenge. And disruptiveness, we call these renewable and these modern technologies disruptive because they are challenging the status quo, the existing energy models, the existing policy models. So we need alignment from all stakeholders. And obviously the policies have to evolve and the infrastructure larger has to evolve. For developing countries, access to energy is still their biggest challenge. You talk to somebody in Africa, poor countries about zero carbon, they would say, what are you talking about? I don't have energy, I cannot afford it. And then energy affordability, second biggest problem they have, they do not have policies, they do not have infrastructure in place, and they do not have money. Concluding remarks, zero carbon, energy transition, it has to be a shared future. It has to be a global future. It cannot be for a particular nation, for a particular country, or a particular continent. Climate change is globally integrated challenge, and billions of people still lack access to refined energy sources, which need to be addressed. What we are witnessing, the unfolding energy transition, is the third major energy transition, and it has four major dimensions: decarbonization, decentralization, digitalization, and decreasing use of energy. And the success lies in a robust technology policy partnership. And localized socioeconomic inequalities around energy insecurity is one of the biggest concerns, and the world needs a just energy transition, ensuring energy and environmental justice. And finally, the planet, which we call a global village, has a shared future for the developed and the developing nations. And my recent books on the topics of energy transition for further reference. Thank you very much.
What an inspiring and action-driving speech, Dr. Muhammad. Thank you. Moving to our third guest speaker for today. He's the Senior Vice President at Honeywell Company, who's going with his speech, which is about sustainability, starts with digitalization. Please help me to welcome Mr. Norf Gilsdorf.
This way, here. Okay. Good morning, everyone. It's a great pleasure to be here. Great pleasure to see so many colleagues and old friends. I want to begin by thanking the organizing committee for inviting me to speak here. I know they've invited me many times in the past, and I could never make it into my schedule. But this year, with this theme, it was absolutely critical to come and attend, because this subject is, as the previous speaker highlighted, it's important to all of our future. So I'm going to talk about how digitalization is really the fundamental starting block to getting sustainable or to get to net zero. And a lot of it can be done today with pretty limited investment. Well, I think we've heard over the last day and a half, there's been a lot of investment in technology and a lot of drive to implement new ideas, whether it be around digitalization, whether it be around carbon capture, to help drive us towards our sustainable goal. But at the center of it is going to be data, which is driven by digitalization, whether it be data to track and measure what we're emitting and where it's coming from, or whether it be the data that's used to implement new technology. And then obviously regulation and performance management are going to be driven by data with the underlying digitalization. Well, the previous speaker, I think, gave us the burning platform. We all know what it is, no pun intended. with the fields he showed there in why we have to solve this problem. And historically, when you look at the environmental area, you know, it's been driven by regulation. It's been driven by the fact that, you know, we tried to manage emissions and meet government requirements. But, you know, with the advancement of technology and digitalization today, there are more reasons than just that to drive sustainability. First of all, it's just good business today, because if you drive sustainability, you're going to be more efficient, you're going to have less waste, use less raw materials, make better quality products. You're going to be more competitive because you're going to be able to respond to your customer needs. And our customers are going to be demanding us to have sustainable plants, sustainable operations, and they're going to demand us to be changing what we're producing. We have to protect our brands. You know, many people in this room are working for big companies, whether it be Aramco or Honeywell or others. We all have to be protecting our brands, and our customers in the globe are going to require it. And that leads to long-term business viability. To be viable in the future, you've got to be sustainable. And then obviously, like we've had for many years, the government's going to continue to want reporting and put regulatory guidelines. So there are many good reasons to be sustainable, but I think now's the time to get on board if you haven't already. Well, Honeywell, let me go back there. Honeywell's been focused on sustainability for a long time. Many of you may not know, but we were the inventor of low global warming refrigerants. If you go back 20, 30 years, refrigerants are extremely harmful at those days to the environment, and we invented the low global warming. We were also, and nobody remembers this either, the biggest producer of catalytic converters. And we invented the technology that made unleaded gasoline and low sulfur diesel. And even when it gets to low NOx burners and you know, efficiency and software around energy, whether it be in buildings or airplanes. So we've been, you know, in the business of sustainability for a long time. But if you look at where we are today, you know, we start off with our process solutions, our automation business, which is very present here in the kingdom. You know, their controls and software drive energy management, performance management, improvements of productivity and efficiency. That's going to continue to be a key mainstay to help drive sustainability. And obviously energy efficiency, whether it be around a plant or a building, using software or controls, will continue to be another big driver for sustainability. And then there's technology, our UOP business with technology to remove carbon, to be the leader in SAF, which is sustainable aviation fuel, using renewable materials such as waste oil or biomaterial. Recent announcement on using ethanol to jet fuel. Or green or blue hydrogen technology. Or the technology to take crude to petrochemicals. Or the recent discussion on the previous talk about battery technology. We're actually leading the way in battery flow technology with multiple trials around the U.S. for very high-level battery storage. And then obviously solutions that bring this all together, technology, software, controls, to help drive a overall solution to the emission situation. Well, when we look at greenhouse gases, and I think the previous speaker gave us a fantastic overview, 50 billion tons of CO2 equivalent are emitted annually. But the interesting part of it is over 50% of it is driven from industrial sources transport, aviation, those areas, the areas that probably most everybody in this room is focused on. And these are the areas which, let's talk about what kind of technologies and how digitalization can help us drive significant improvements here. This is an important way to look at it. I think we all need a framework on how to address sustainability. And obviously it starts with having a vision, a goal, and a plan. But maybe even before that, you've got to be able to understand where you are. And if you look at the center of this chart, this is where digitalization comes in. It's around operations and analytics. Because it starts with, you have to be able to measure. As all of us know in business, if you can't measure a result and visualize it, then you can't control it and you can't drive improvements. So it starts with measuring. So we're going to continue to need to drive new technologies to be able to measure things, to be able either with soft sensors, improved sensors, to be measuring in plants, better way to gather data. And then you need to visualize it. Visualization is not talked about, but I always believe being able to see the problem is a good fundamental starting point. And when you look at the 4IR Center that Aramco has built, that's a fantastic example of once you begin to see and visualize what is out there, it really helps you drive towards solutions, improvements, and optimization. Obviously, you have to report, and then once you've got that, you can begin to control and optimize. That's why I say digitalization is really at the core of sustainability. And a lot of that digitalization is already able to be done today with technology that exists, technology that you're implementing in your plants. And then obviously at the end is going to be your reporting, your assurance, and obviously optimization that comes in. But having this roadmap and understanding where to begin, because we hear a lot of talk in the industry about a lot of these emerging technologies which are going to drive sustainability. That's great. But as the previous speaker said, some of those still need improvements in cost, some of those need improvements just in technology. But today we could start implementing significant change just by using what we've already got. Here's a good way to look at it. To get to net zero, you've got to kind of work your way down this step chart. There's operational efficiency and energy efficiency. That's stuff we can do today with the techniques and tools we've got. Then we've got the new technology, the biofuels, the green hydrogen, the blue hydrogen, the like. Then you've got carbon capture and reuse of carbon capture, and ultimately the renewable generation previously discussed. That gets us pretty much all the way there. Obviously, carbon offsets and trading probably going to take the very last bit. But let's talk about how we can make an effect on that very beginning of those first few steps. Well, that 15%, energy efficiency and operational efficiency. Again, technology exists today to enable this. And whether it be asset performance management that many different plants and industrial sites are implementing, advanced process control, energy management software, all of this can be implemented today, and all of this helps drive significant improvement. And then these can be tied together into an energy framework. And then you add artificial intelligence, you add machine learning to that, you can be able to then build together a sustainable solution. One thing I would add here, and it was interesting in the opening remarks yesterday by Dr. Katani, is how you can look even more broadly once you've gathered this data and you've begun to optimize. And this is where quantum computing is going to come in. And quantum computing is going to be able to let us take these massive amounts of data that we've got and be able to do optimization scenario in an incredibly fast time. That's another area that Honeywell's focused on, another area of tremendous interest going forward. Now we look at that next 50%. Now this is where we're going to need to bring in the new technology, whether it be blue hydrogen, green hydrogen, carbon capture technology. But to be able to implement this successfully, digitalization is another key component. And this is where digital twins, simulation, other technologies around modeling help us enable us to predict what the implementation of this technology will bring us and how to optimize this technology, how to integrate this technology into our existing facilities. Being able to use digital twins today to be able to optimize equipment monitoring, to be able to predict use thermodynamic models to predict what is the optimum or what is the minimum output of CO2 or the most energy efficient. And then use that with your tools to be able to drive back to your proponents what they need to be achieving, setting of targets. All of this is available today, and it's an exciting area that, again, we can implement with limited costs. Bringing it all together is something we call Honeywell Emissions Suite. Honeywell Emissions Suite, this is an example around methane. This is basically a suite that starts with measuring what is it you're emitting, where, and being able to pinpoint exactly where the problem is, what the quantity is, what's driving it. Being able to monitor it, visualize it, then being able to predict it. And then once you can do that, you can begin working on reducing it, reporting it, and being able to develop solutions around improving it. And this involves things like Signal Scout, Rebellion cameras. This enables you to visualize things quickly. And then there's a software solution that enables you to bring all this data together, visualize it, report it out, and then bring your tools in to help optimize. There's a good demonstration of it in our booth here if anybody has an interest. But this is just an exciting area that we're working to develop to help people visualize. And this isn't just for one site. This could be for looking at all your global sites around the world, something that we're using today in a lot of our manufacturing. Here's another example. This is an example we've been doing for the last year or two in the North Sea with London. This is actually where we've used the process models, the digital twin, as well as asset performance management to basically optimize the performance of an offshore rig. We're able to reduce energy by $1.2 million a year, but more importantly, 5.6 thousand metric tons of CO2 have been reduced. There are many other such examples out there, again, with people taking existing technology, using and leveraging in a way to make themselves more sustainable, but also more economically efficient. So in summary, digitalization, I still believe, is at the core of getting us started on the road to sustainability and net zero. It's something that today we can implement with limited costs while the new technology is being developed. And it starts with measuring, visualizing, recording, and then controlling and optimizing. But to be successful, we need to empower our employees. All of our employees need to be part of this. They need to have it part of their performance metrics. They need to be measured on how well they drive energy efficiency, how well they minimize waste. It's about the community all working together. As the previous speaker said, we're all on this planet together, and we've all got to be committed to this goal. And obviously, sustainability, it's energy, it's CO2, it's waste, and as again, previous speaker, a lot of it's also about water. And at the end of the day, it's driven by operational excellence, something we've talked about for many years, something that we can begin implementing today. So thank you very much. I very much appreciated the ability to speak with you today. Come by our booth later if you have any questions or want more details. Thank you.
Great presentation, Mr. Norm. Thank you. Before we move to our next speaker, we would like to have a moment of recognition for our last speakers. So I would like the Vice President of ISA and the last speakers to come up to the stage. Moving to our next topic, which is about flare reduction via predictive process analytics, presented by Mr. Scott Hale, the Director Analytic at Co-Engineered Solutions, and Ghufran Al-Abbad, Process Engineer at Saudi Aramco.
Quick test this morning to see which mic to use. So good morning. My name is Scott Hale. I'm the Director of Analytics for OnPoint, which is part of Coke Engineered Solutions. And I wanted to take an opportunity to talk with you today and introduce my colleague from Saudi Aramco, and she's going to tell you a little bit about how our partnership has worked together, and then I'll conclude with some of the results.
Thank you, Scott. Assalamu alaikum. Good morning, ladies and gentlemen. My name is Ghufran Al-Abbad. I graduated from Michigan State University with a bachelor degree in chemical engineering. I am a process engineer at Saudi Aramco company, working under process and controls department. And I'm working with the flare and relief systems group, where we support both upstream and downstream operation facilities. It is my pleasure today to present to you the initiatives and the new proactive approach towards achieving net zero emission within Saudi Aramco facilities. In these slides, we will brief you with the master gas system, the flare monitoring system, the partnership between Saudi Aramco and OnPoint to develop a predictive analytical solution, the concept behind this solution, and what's our next step. The prevailing practice worldwide is systematic flaring, where gas is burned off and wasted. Saudi Aramco was one of the earliest oil companies to have recognized the value of gas. And so, in 1975, Saudi Aramco developed a gas processing and transmitting system which collects gas and takes it to the market to produce fuel and feedstock for the kingdom. This comprehensive integrated system, known as the Master Gas System, is one of the largest industrial projects in the world. It consists of more than 50 gas oil separation plants, 10 mega gas processing plants, 3 natural gas liquid fractionations, and more than 4,000 kilometers of a cross-country pipeline network. And currently, it has a handling capacity of 18.3 billion standard cubic feet per day of sales gas. So this system enables Saudi Aramco to utilize all produced gas for power generation industries, petrochemicals and refining industries, cement and desalination plants. Further, on implementing of the master gas system, our annual flaring has significantly reduced to facilities routine and emergency flaring only. We have realized that even such a small amount of flaring could have a detrimental impact on the local environment and human health. So, as a result, the company realized and established at a highest level a commitment through issuance of a corporate flaring roadmap to minimize flaring and not to only meet but to exceed the kingdom's regulations and vision. Hence, we have developed an innovative in-house real-time flare monitoring system which uses fourth industrial revolution technology to effectively measure and control flaring in real time from facilities. By utilizing the flare monitoring system, we were able to develop a source-wise measurement system, monitor and analyze flaring, develop an annual flare minimization plan to mitigate flaring, and develop standards and procedures to govern the program. So, Further, implementing the flare monitoring system as a reactive approach resulted in 60% reduction in flaring. Our ambition towards achieving net zero emission inspired us to take a further step and be proactive. In collaboration with OnPoint, we have developed a flaring reduction predictive model that has the capability to monitor, predict, and notify the end user with any upcoming flaring events ahead of time. This will enable us to stop emitting greenhouse gases before any flaring event happens. And this will support Saudi Aramco to achieve its goal of net zero emission by 2050. And now I will leave the floor to my colleague, Scott Hale. Thank you.
Thank you. So we've talked a little bit about our partnership of how we've worked together. So I want to walk through what that looks like. So we talked to OnPoint, and OnPoint is really, we have to look at the overall umbrella of where OnPoint exists. OnPoint is part of Koch Engineered Solutions. And within that umbrella, what you see is we have John Zink Hamworthy combustion, which has expertise in flare gas minimization, process burners, and overall combustion knowledge and expertise. We're also paired with Koch Litch, which has mass transfer separations knowledge, combustion, and equipment. And we have OnPoint, which is the digital analytics arm within Koch Engineered Solutions. So all that together was why we felt like we would make a good partnership with Saudi Aramco and their flare team. We worked together. We worked with their process engineers, their domain subject matter experts, and also the data experts. So we'll go to the next slide and talk a little bit of how we approach this. And it's 4 pretty basic steps that were simple but not necessarily easy to do. The first where we started was we had to define the outcome. And again, straightforward, but how did we go about doing that and really define what that shared vision will look like for this next step of how we extend predictive analytics within the flare management system. One thing we talked about within OnPoint, we have a combination of software engineers, data scientists, and process engineers. And why we felt like that combination of data scientists with process engineers was very helpful, gave us an advantage. We start talking about, to work through this, we define that outcome. We wanted to then come back and get data. And we start talking about data. We're looking at both raw data, but also the P&IDs, process flow diagrams that we worked with to pull back from this particular use case we're working on. Why we think that's important. If you're just looking at this from a pure data science standpoint, you're going to ask for raw data. If you're going to look at this from a process engineering standpoint, you're going to get the process flow diagrams and different diagrams, but maybe not emphasize as much on the data. By blending that together, we're able to work through this in a little bit more detail. What do I mean by that? When we got the first data set from Aramco, we said, hey, this is really helpful, but we need more. We need more both from the standpoint of the breadth of data, we needed more variables, and we also needed more data from the depth of variables. The data we initially had was aggregated up. And so to do the analytics we wanted to go do the machine learning, we needed more data. So by blending our expertise with process engineering and data science, we were able to understand the process flow diagrams, understand what data we could go ask for. We also leveraged our colleagues within Coke Glitch for this particular use case, who had experience, who had designed the particular piece of equipment we were working with, and they were able to help guide us through this process to understand maybe there was additional data we could look at. So by pulling all that together, when we were able to go back to Aramco and ask for specific data points that we needed that would help us with this analysis. So where we initially had, I think, the initial data set we received was about 6 variables over a year's worth of time. We were able to go back and say, we need additional variables, and with that knowledge, we asked for 22 additional variables, very targeted in what we needed to go do, and we were able to get additional years' worth of data. So we started with a year's worth of data, 22 variables, at a more granular level. We were able to work through that, working with our data scientists and our process engineers. We were able to iterate internally on a model that we felt would be helpful to predict the flaring for this particular piece of equipment. We iterated internally, had a decent working model, and then we said, okay, we need to follow back up with our Aramco counterparts to get some feedback from them. We had some questions to ask, and at this point, they brought in some of their domain expertise to help us with understanding some of those questions, what was going on operationally. We iterated on that model a few more times and felt like we had a reasonable model working, that we circled back with Aramco and started to do a management review. And we were able to go through that management review and get some good feedback. This entire process took us a month. When I say it took us a month, when I say that out loud, that feels like that was a long time. When we step back and look, within that month, we were able to establish a shared vision for what we needed to go accomplish, iterate on several data extracts, several micro iterations of developing a model, a machine learning model, that used an ensemble approach to generate that. So we pulled multiple different aspects of machine learning into that to generate that model. And you have several management reviews. We felt like that was a pretty aggressive schedule. So maybe we'll step over and look at the results we're able to get. At a high level, for the year's worth of data, we were able to develop a model that was 90+% accurate in predicting results with at least an hour lead time for pre-event notification. So let me walk through and see what this looks like. See if I switch mics, does that work okay better? Okay. So what this chart is intending to show, oops. in the background, this is a subset of the data that we had for the year. And it highlights a few of the key points we wanted to share. So within the background, we have the ambient temperature for that day. And that temperature is a competing factor in the model, but not the leading factor of what's being really predicted. But it helps set the context for the day. The black line is where we, based off the data that was provided, indicated that there was a flaring event occurring. And then the blue line is where our model predicted a flaring event to occur. So in this case, we talked 9% accuracy. We can get into the semantics of the confusion matrix and what that looks like. But at a high level, this right here would be what we'd call a true positive. We predicted the event to happen up to an hour before the event, and there actually was an event. And we have true negatives along here where we predicted there would not be an event, and there was not an event. Now, just for the sake of transparency, we were not perfect. We had a few cases where we predicted that there might be a flaring event, and there was not an event. And we had a few cases where we did not predict there would be. So let's talk a little bit about how this model can be applied. In this case, this model was used for purely historic data, so kind of a backcasting model. In that case, if you're having continued routine flaring, you can backcast with historical data to understand what may be leading factors. Machine learning that we are applying does a very good job at identifying patterns that humans may miss or just may have a blind spot that they're not connected with why something's happening. So looking historically, it can identify patterns it's happening to help resolve those. As we've alluded to, it also works, this model can also then be applied with current data to predict what may happen in the future. So if you're having consistent routine flaring, we can set up that model where you can pass data into it, current data, and it will indicate with an hour ahead of an event what may happen. And so we've seen that's worked in the past where we've deployed this model, have real-time data running through it, indicated to operations what may happen ahead of time, and then allowed them to then take a corrective action to reduce their flaring, to avoid the flaring altogether. When that happens, the model changes and we have an approach for what we call model lifecycle management that allows us, based off performance metrics of the model, accuracy and performance metrics, and data signatures to adjust that model in real time as needed. So as we look through this, kind of what are some next steps we're going to move forward with our partnership? Well, we've completed one iteration of our cycle, one phase of this. So we're starting back at the beginning of our process. What are the outcomes we want to try to drive to lower emissions by advanced analytics with our partners at Aramco, and how we want to move forward? One tangible way we want to do that is we're looking to deploy a predictive model within the Saudi Aramco's 4IR center and have that running in there. So as we conclude, we discussed briefly today on Saudi Aramco's master gas system and how their flare management system is used to monitor, track, and identify historical and in real time flaring events. We talked a little bit about our partnership between Saudi Aramco and OnPoint, and really Koch Engineered Solutions. We shared how we worked through this process in about a month to be able to develop this model and some of the outcomes we were able to achieve in our next steps. So I want to take this opportunity to thank the team at Saudi Aramco who's partnered with us and look forward to continued collaboration. We'll take Wufan for participating and sharing the stage with me today. I appreciate all your help and time. I think we may have a few minutes for questions, and if not, we'll be available for questions later today. So one question, so appreciate the time. Thank you.
Assalamu alaikum. Thank you for your presentation. I saw in the graph, the green-blue graph, that the data was for 2019, I think, and in June 2019. my question is, how far are we with that? Is there any actual measurement on that? Is there any improvement? Or was that only for developing the model, and then you are looking forward to further optimize that?
Make sure I heard the question correctly.
Right.
The initial data that we shared was for 2019. And is there any improvement on that? We have gone back and looked at that model. So was the question around the improvement of the model or improvement of the
The
flaring?
improved model, in which stage is that tool project optimization? Now the data is at 2019, I think.
Yes.
Now we are at 2022. Where are we now? Are we already optimized? Have we made some progress? Have you seen something? What is the status of the tool, of the optimization tool by today?
Yes, so the data, we've been recently developing the model. We used 2019 as a baseline year to do that, so we've looked at that. The next step we're going to look at is how do we start looking with current data and running that in the Saudi Aramco 4IR Center. So we have looked at some more recent data and have seen some improvement both in the model and the performance of the flaring, but that's kind of the next step.
So you are saying analysis phase, you said?
Yes, yes. Thank you.
Thank you, Ghufran and Scott. Now moving to our next presentation, which is about smart access and carbon sensing technology, presented by Muwaffaq Al-Medani, Chief Operating Officer at Takween Automation Company. Please help me to welcome Mr. Muwaffaq.
That's fine. I'll do without the pointer. This is for the right hand. Okay. Good morning. I will be talking today about framework. Framework is a wider scope than a set of technologies. It will include a mechanism to use the technologies and some procedures and policies. So though the focus is the technology, but the framework will cover a little bit more than that. I come to you from VISLOR. VISLOR, for those who haven't heard of it, is an American research company based in Arizona. Why is this relevant? Because in Arizona, actually, we have similar climate to the climate in Saudi Arabia. We face the same challenges, and we're dealing with the same issues, and we're developing similar technologies, by the way. Half of our staff at VISLOR work in the research. By research, I mean academic research. We are connected with Arizona State University. Many of us, half the staff, have been college professors in the past, or now, myself included. And Arizona as a state, as the government, as the authorities, have invested and tried to compete with the Silicon Valley, actually, by positioning Phoenix as the next Silicon Valley in the United States. They have pumped quite a bit of resources, funding, infrastructure. Honeywell, IBM, companies all over the world now have huge facilities in the state of Arizona to help in moving the state to be a leading state in technology. One specific technology that I will be talking quite a bit about today is blockchain. Blockchain is part of the framework that I will be presenting here. And I will explain why blockchain, by the way, is critical to what we are trying to achieve here. So moving forward, I tried to use the pointer here, but unfortunately, this isn't working. So let me do it from this side. So a year ago, exactly a year ago, in October of last year, it was announced that Saudi Arabia joined over 100 countries, actually, to achieve the objective of net zero emission. This is a huge look, I mean, at the scale of the problem. It's a big country. The industrial base is widespread. I remember first time I drove to Jubail, and I was seeing factories left and right, petrochemical factories and others. And you just think about the scale of what will it take, really, what will it take to achieve the objective of net zero emission with such huge industrial base in a vast country like Saudi Arabia. It's more than just technology. It really takes a framework. I put them into three categories here. There is the legal and business framework. Everything must have legal and business settings. Otherwise, technology will be just technology. You have to put it in the right framework to move on. And I put in red here carbon credit. I will be saying a lot more about this. This is the money, okay? There's always money involved here. And any initiative will have to consider the cost, okay? And the incentive to do what the objective is. The second pillar here is the solutions. This is the technology, okay? This is what we bring to the table and what many other technology companies bring. This is the 4IR, the optimization, the digital twin, and I will be talking about all of these, okay? And then there is the mechanism. You put the framework and the solutions, and there has to be a mechanism of how this is used to achieve the objectives. So I will address all of these, starting with the suite of technologies. What do we want to do? We want to measure, analyze, optimize, and record the CO2 emission. All of these are critical. All of these are critical. And we'll be using 4IR technologies. Tokenization is a key. It's a way to measure what is being emitted and what is being saved. And speaking about, for those who are familiar with the concept of Saudization and the levels and Saudizations, this actually has some resemblance to it, okay? Because here you can assign level to compliance with net zero emission. And tokenization and carbon credit will give us the way to measure and rank companies and structures based on their level of compliance. Smart living technology, many ask me why smart access is at all part of this discussion if we're talking about net zero emission. Well, smart access used to imply the physical access to a facility, you know, gates, doors, and stuff. That's not what this is all about. We are talking about digital twin, artificial intelligence, machine learning, all the optimization that has already been deployed in many factories, in many structures, in order to optimize the operation. And that's where energy saving will come to play. Analytics, and I will talk about the machine learning and analytics. Blockchain actually is kind of the new technology here in the block, but it is making headway in the US and in Europe, and I see great opportunity here, especially after the talk I heard yesterday about the energy map that was done for Europe. I will save that to the end. So there is a framework where actually private sector and the public sector will have to cooperate to achieve the objective. The pillars are shown here are technologies, okay? We've heard about almost all of these pieces of technologies. You know, this morning, great talk actually just before my talk, and yesterday. The key here that there has to be cooperation between the private sector and the authorities here. There is no switch you turn on and you achieve net zero emission. There has to be a cooperation. That is why framework is actually a key here. There is, you know, scientists and engineers love to see architecture diagrams, and I'm going to walk with you on this diagram. Unfortunately, the pointer is not working here, so bear with me. So I will use the numbers here. So I want to take you from the bottom, which is number 1, to the top, which is number 7, and link the flow here, okay? On the ground, you see actually where the rubber hits the road, okay? It is where you achieve actually the objective by reducing, by monitoring, by optimizing. On top, it's where the government or the authorities actually put in place the policies that have to be followed. In between 1 and 7, there are steps, and that is the framework that we are proposing here. Looking at structure, which could be a hotel, could be a factory, could be even an airport, could be a warehouse. And you know, I lived in Chicago for like 20 years, and I have seen warehouses in the Chicagoland area mushrooming all over the place. A warehouse is 500,000 square foot in size. Some of them are 1 million square foot in size, okay? It's incredible, okay? And most of it is run by machines, by conveyor belts, by robots. But what they do, they still use energy excessively. For heating or cooling, in Chicago actually when it is cold, you know, it could get to 20, 30 below zero, okay? Really, easily, okay, Fahrenheit speaking. And summertime, it also can get to 100, 110 degrees during the summer. They heat and cool the whole facility. This is wasteful, and the same applies to hotels. If the occupancy level in a hotel is low, unless you have something dynamic to monitor, if you have no visibility, you have no control. You have to have visibility. So smart living here, I'm trying to generalize the terminology of smart access. We're talking here about smart living, smart working, where you actually have sensors to monitor what's going on in the facility. These are your eyes and ears. And I just mentioned in number 2 actually proximity processing and CO2 sensing. I have a slide about proximity. Proximity is the GPS inside structure. You would like to know the location and the direction of movement of assets. Assets could be people moving around, could be robots moving around. Anything that is of value is an asset. If in a warehouse, 90% of your people working in this corner of the warehouse, why heat up or cool down the entire warehouse, especially if they are closed, you know, if there are doors or this actually, the proximity technology allows you to know where your assets are. And this is done through collection of data that you get from sensors, but it is not possible or feasible to put 10,000 sensors in a facility and send all of them through the network. You have to have edge computing. That is the issue of IoTs, gateways that communicate with the sensors, and those gateways and IoTs doing some processing. Edge computing is becoming more and more prominent. I don't want to say competing with core computing, because you still have core computing, that's where the AI is, but it's very important that pre-processing of data is happening also at the edge. With all this data, it will have to be sent through the network, whatever the network is, it doesn't matter. 5G, 6G, by the way, is coming soon. And where you put this data is in the digital twin. And we heard this morning talk about digital twin and how important it is. We have to model a structure, a process in the computer. Yesterday, I think the digital twin was talked about as engineering and operational, okay? Well, you can look at it this way. From our point of view, it's about the modeling, the topology of the structure. Hotel, for example, how it is laid out. If it's an airport, how the terminals are placed. It's about the assets, and it's about the processes. What's going on there? In a factory, you have people and equipment, machinery moving. That is being monitored in real time. It is critical for the analytics to understand how the assets, 2 minutes? Oh, okay, I guess I need to move faster here. It's critical to know how things are moving actually. Then there is the analytics, which is in the core usually. It is performing the optimization, and it's feeding back what the optimization needs, so you achieve the 30% or so optimization that you need, and you write the data in immutable data records. That is where blockchain comes to play here. It's not hackable. That is the value that comes to the table. And of course, policy making has to come from the government, and carbon credit actually is assigned. This is kind of the same thing, but in a pyramid view. Unfortunately, I'm running out of time. I need to get to the end here. But this is the layering as you go through. Usually telecommunication people love this kind of diagram because it shows you how you move from one layer to another. This is the triangulation that you do actually to do the tracking of resources. This is a case of a factory where you track assets, digital twin modeling, and it is taking the physical structure into the digital model. Distributed computing, it has to be at the edge and at the core, as I mentioned, due to the size of the data. And the blockchain is a key here. And here we offer as a company the Chain Rider blockchain. This has been deployed all over. It is in Qatar. It is used in multiple industrial and educational areas. Two things here that are very important. It is the generation of the network. It's the stakeholders. Every factory, every structure is part of the network on a blockchain. And it is the smart contract. Smart contract is between the entity that is participating in this framework and the government. I'm going to skip through that, but these are all involved in blockchain. And this is what I would like actually to work with Aramco, okay? The presentation that was yesterday about the energy map, use servers. If we can use the same actually approach with the blockchain, that's how Europe is moving, that's how United States is moving. Let's put it all together. How does it work? The government will set up carbon credits, okay? And based on the size of the structure, a company will get carbon credit, okay? Proximity, processing, CO2 sensing, IoT devices will measure and make sure that we capture all of that. I need just 1 minute. Then the AI server will optimize, will look at all of this data, and the data is captured on a blockchain. This is immutable data. So what happens here? At the end of the year, you as a business have your budget for CO2. If you've met it, great. You get cheaper carbon credit from the government. This is the incentive for everybody to be part of the solution. If you exceeded as a business your allocated budget, then you will have to purchase more. That's why I say this is similar to Saudization, okay? You get greener, you get yellow if you spend too much, and this is part of the collective social responsibility that has to be put together between the private and the public sectors. So we're hoping that all of this will be actually designed and manufactured in Saudi Arabia. Feel free to approach me or my friend, Mr. Abdullah Khalifa. We are working, and with others actually, on making this available in Saudi Arabia, and I hope we can follow up. I unfortunately ran out of time. Thank you.
Thank you, Mr. Tawfiq. Very interesting and rich topic, but unfortunately we have a really tight schedule. So the next speaker is from Sadara Chemical Company again, Mr. Alastraf Ibing, a sustainability specialist from Sadara, who's going to talk about greenhouse management. Mr. Alastraf, the floor is yours.
Hello? Hello. Okay. Assalamu alaikum and good morning, everybody. My name is Ashraf. I am from Sadara. So it's always a great feeling to be with conferences and events like this. And I technically had a very good learning from the speakers earlier. MashaAllah, it's very good. And this, I think, will probably help us propel further with our GHG emission efforts. So I'd like to thank the organizing committee, specifically Dr. Muhammad Al-Inazi, and of course, our Sadara management. And my presentation today will cover, actually, GHG emissions management. This is how we do things in Sadara. So Sadara, as you know, is a very young company. Technically, we developed this program for we started in 2019. We started reporting our GHG emissions via our sustainability report. So let me go through and walk through my presentation. Okay, so you have here Sadara, our nominal complex capacity is 3 million tons. We are a JV between Saudi Aramco and the Dow Chemical Company. So we, as management said, we were born big. And we are the largest petrochemical plant ever built in a single phase. So we have 26 manufacturing plants, and we have 14 plants completely new to the kingdom with 20 billion plus USD investment. So this will give you a little bit of understanding of how big Sadara is and how we are managing our GHG emissions. Right now we are doing it, we have some automation in collecting GHG data, but heavily our collection is manually done. And we are fortunate to have good and competent focal points. Some of them are here. And yeah, let's go to the presentation itself. Okay, so I'm going to discuss about the program background and the GHG accounting performance activities, how we do this stuff. And of course, what are the digitalization aspects of GHG? And what's our work process? So this is the very core of the work process, which is established very recently. And technically, this is a mirror image of our energy management system. And of course, what's our net zero carbon? So, oops, sorry. So you have here, Sadara is taking ethane and naphtha, and we are processing it into various products. So, that includes plastics at the bottom of it. Then we have the basic chemicals, propylene oxide, and we have ethylene oxide. and we have the isocyanates group, the TDI, PMDI, and the whole chain itself. So all of that, the nominal capacity, as I mentioned earlier, is 3 million tons. So you would be wondering, if you have 3 million tons, how much CO2 are you producing, right? So for us, we report our performance based on GHG intensity, because as you know, production is the relevant variable. That's the variable that changes from day to day, and that is the way how we do the reporting itself. But we are also counting our GHG emissions as part of our indicator. So the GHG accounting, as you have seen earlier, we have scope 1, scope 2, and scope 3. And I think there's a little bit of deviation with the data. I think I saw earlier 2% from chemical industry, but probably that's the way how the accounting does work. So we have here, just for everybody's information, GHG scope 1 is the one that is produced within your facility. GHG scope 2 is the one that is produced by another facility that you are taking in. Specifically, that is more on electricity and the steam that we import. Scope 3 is more elaborate, if you will. Right now, we are not yet doing scope 3, but probably we'll be going to that road in the future. So we have alignment with the various requirements from government, from bodies. And as you can see, we have the Saudi Green Initiative, we have the IFC, and you also have the WRI, and so on and so forth. We have also the Paris Climate Agreement. So all of these requirements we have addressed in our, at least, it may not be fully, but we do address these requirements in our management. Okay, so the GHG emissions management is technically to have a systematic. So with the complexity and with the number of people that you have on site, we want to have a systematic and robust methodology to continually improve our GHG intensity reduction target and enhance the management system and comply with the applicable legal and stakeholder requirements. So when we talk about the applicable legal and stakeholder requirements, we are talking about our shareholders, we are talking about Royal Commission, and we are talking about other agencies. Of course, the digitalization part, mainly it is heavily more on the automation part right now. It will save us a lot of effort in collecting data. This is the first struggle that you face when you are like building the system from the ground to the top. So we simplified the laborious task of manually consolidating the data to prevent random and systematic calculation errors and to explore opportunities to apply artificial intelligence. Now we have a policy. We have been talking about this policy. This is embedded in our EHS&S policy. This was driven by Responsible Care. And our policy is to implement a GHG accounting, reporting, and management system in accordance with the Kingdom's vision requirements. GHG emissions will be reduced and specific targets will be set. So at the moment, Sadara's target is to reduce the GHG emissions by 2.5% within 5 years. So that's our 2025 target. Now we have a team. So for us to manage the whole, the collecting of the data and to optimize the operation itself, we have established the footprint team, or we call it the Energy and Resource Optimization Subcommittee. So just a little bit of background, this Sadara is the Sadara Sustainability Council. We have 5 different groups. They represent all of the sustainability, we have people, we have planet, we have the environment, right? So these 5 pillars, they represent all of these sustainability aspects. And one of that pillar is basically the energy and resource optimization, or it was renamed to climate change. So we have appointed champions from GHG, from energy, water, and material effectiveness. So these are the 4 metrics that you normally see when you read reports from Sadara, from SAVIC. So these guys, I have worked with, or should I say, I'm working with at least 35 people just to get our GHG data. And we're doing it on a monthly basis, semi-annual, and annual basis. Of course, these guys are from the manufacturing and admin departments. And as I mentioned earlier, there are element champions that have been appointed, and we have established a team charter. So team charter is important to cascade it to various leadership. Each of these guys, they come from different plants, they have different managers, they have different directors. So for them to have a feel of what exactly are we doing, we need to have the charter itself in place. Okay, so we started the GHG policy. This is the very core of this presentation. Then we have set the objectives and targets. So objectives and targets for us is not only how you reduce your GHG emissions. we learned earlier that competency of employees are also part of that. So in our management, we also include that as part of our objective. So we have the planning requirements. We identify the needs and expectations of our stakeholders, our interested parties, if you will, and we define the scope of our GHG management. So GHG management for Sadara is not only manufacturing, it includes also administrative areas such as buildings. And we have also the risks and opportunities. We identify that because that's the very core of like what exactly you're trying to solve, right? So we do identify the risks and opportunities, and we ranked it. I think you guys are familiar with that. And then from there, we have our action plan. So we have additional things in here. We have the GHG review, which is part of the energy review. And this is a very systematic way, like you're identifying your sources, the major sources until the very last of them. And then we identify which of them are significant emitters. And from these significant emitters, we actually exploit, if you will, or explore how we are going to improve the performance itself. And then we have our GHG baseline, which is 2020. This baseline has been changed twice already. And of course, the baseline considerations includes management direction, apart from the stability of your system. Our GHG performance indicator is basically our intensity, the GHG data accounting. How we do that, we have developed a separate procedure. This is the protocol. It says like, what are you accounting from what sources, what sort of measurements are you going to take? And of course, we have the improvement planning using the Innovate Act tool. So we have this Innovate Act tool. This is rolled out across all of Sadara, wherein anyone from the company, they can suggest any sort of improvement that they think that would be useful for our GHG reduction. Then we do the collection organization of data, we do the optimization, and we establish design improvements. And of course, procurement is also part of that, procuring energy efficient products, equipment, and services. And heavily on our competency of the employee, we do have programs for that. And of course, we comply and communicate to IP requirements. So comply for us is, as of the moment, is mainly more on reporting itself. And then we have the key parameters monitored. So I think we have learned also earlier that you have a lot of things to consider, for example, for the flare, that you have very specific parameters that needs to be monitored, just an example. Then we verify measurements and we validate GHG data. Then we do the calibration of instruments, we evaluate our performance, do CAP analysis, and we verify correction and corrective actions. So this whole process itself, it's going to probably lead a couple of items with non-compliant stuff, if you will. So we do an automated version of action planning. We call it the event and action tool that specifies what you do, who's going to do what, and what sort of date. And if there needs to be an update with our procedures, we do that. And of course, we do the closure of our compliance requirements, if you will. Also, we do root cause investigation for specific, what do you call this, triggers. So for example, if you exceed your GHG emissions by like 5%, you have to investigate why, things like that. Then all of this performance data, it goes to what we call management system review. So this goes to the director level, including to the CEO level, where in every year they do check how are we performing in terms of our GHG performance year on year. Then it goes back to the whole thing itself. And then we have the internal assessment. This is done by our EHS assessment team, where we do periodic audits to our facilities. And we also organize a third-party assurance. So as I mentioned earlier, the heavy part of collecting data is manually. So we have hired third-party consultant to make sure that our process is assured, that our methodology that we use is correct. And that is also reflected in our sustainability report. And last but not the least, we have also the technical assessment by our by our shareholder. So all of this stuff, they come together and they make up our GHG emissions management. And of course, just any other ISO, what they call this, ISO process, the continual improvement is there. It should be there. Okay, so what about the digitalization? These are specific aspects only that we have included in here. We have an existing software in Vision that is available to pull specific data and to organize activity data from specific sources, just like our boilers, our incinerators, our flares. Then we are now upgrading this software to include other GHG activity data and explore artificial intelligence. And improvement ideas, as I mentioned earlier, it's in the Innovate tool. This is highly automated, if you will, wherein if somebody raises the idea, there are considerations there, and the improvement engineer does the whole thing. I mean, the evaluation of the project, not the whole thing. And then we have the corrective and preventive actions, which is done automated by event and action tool. So this is how we consider the digitalization, but mainly this is more on automating the system itself. So we do report our GHG data. As you can see here, we subscribe to a couple of things. We have our sustainability objectives. We align our data with the Saudi Vision 2030 requirements. We also have the TCFD alignment and the SDGs contribution, and of course the UN Global Compact. So our base here, just very quickly, we have in 2020 we have 6.5 million tons of GHG, CO2 equivalent. So scope 1, this is the one that we produce inside. It's around 66%. Scope 2, the one that's energy indirect, it's 34%. So this is the breakdown. Most of it you can see here. It's on fuels. We have stationary combustion. These are, the boilers, the furnaces. Stationary combustion, imported fuel, that's from the outside. Stationary combustion, imported fuel produced. So whatever fuel produced from the cracker, we also account that. Just because we did not export it, we are not accounting. But in our case, we do account everything that we burn because we're producing GHG, right? Then, of course, we have the incinerators, we have the flares, and we have the electricity. So mainly you have electricity, you have combustion, and you have the incineration as the big part of the GHG emissions. Now, this is the profile of our performance since we started this program in 2018. So you can see there the profile. It's 2018. That's the first time we met our nominal capacity. Then 2019 came. We increased a little bit of our production, and then here we go with 2020 and 2021. You can see a declining trend. And for 2022 year to date, our value is around 1.9 something. And you can see our target is in 2025 is 1.983. So as I mentioned earlier, our plan is to reduce GHG intensity by 5%, but we already met that target in 2022. So this is the thing with when you're doing management of this stuff, you have to set the appropriate target. So in our case, we will be re-evaluating our target. Probably we'll be changing this target not only to 5% in 2025, maybe 9% or whatever. So that will be coming from the forecast of production. We also consider that in our target setting. Here are the sources. You have seen this one. This is only to illustrate to you that where exactly did we reduce our GHG, the efforts that has been done by the team. So you can see here electricity has a big part. Now there's a trick here. Not because it is not an actual reduction, but because when you obtain your emission factor, you make sure that you get it from the right source, and you have to be consistent with that. So in here, you can see in 2020, our emission factor is 0.7544 kg per kilowatt hour. That is based on IEA factor. But in 2021, we updated it based on KSA factor, which is 0.568. So you can see the difference there. It's huge, but you have to take the more accurate version of the factor itself. Now we are going to how we do the improvement in the GHG itself. First, it's in line with the energy review. As I mentioned earlier, you identify your sources, the big ones, the smallest ones, and you say, okay, this is the GHG emissions, and you consider what's the forecast, and you will have to consult with operations. Hey guys, what do you think we can do about this? Then the second one is we have the substantial operational experience. Some of the expert guys in operations, it's like on spot, they know exactly where in their equipment they can reduce further GHG, and it's very good. And we have also the new discoveries. New discoveries are just like, they're like sudden, they just came. They didn't come to the repertoire of the most expert guys in the room. Probably this is coming from the new guys, from 1 or 2 years in the plan itself. Now there's another one we missed here. We have the Sadara Transformation Program. So as you know, we have the National Transformation Program. There, where you identify specific, specific initiatives to help save your energy costs and all other costs. Okay, sorry. So just an example, these are the reduction initiatives that we have identified. So we have 51 GHG reduction initiatives that has been evaluated. Actually, the actual submission were like 400 something. So they filtered it up and they came up with this one. And the expectation from these initiatives would be 270,000 tons of CO2 equivalent that will be reduced. So a couple of examples in here. We have the boiler fuel switch. You have automated steam venting. And you have specific optimization measures, and so on and so forth. Some of it are, they call this, they are no cost. Some of it are investment type. Some of it are feasibility or study type. That's how we categorize these initiatives. Now, how do we network and collaborate? This is very important for us to learn the best practices in this industry. Of course, we have our shareholders, Saudi Aramco. We do the annual GHG reporting to them. We have quarterly environment and health report. And we also conduct, they also conduct and sponsor GHG training and workshops. And of course, for the Dow Chemical Company, another shareholder, we have the annual GHG data. And we also have sustainability meetings with them. Then we have the Ministry of Energy. We have the second energy cycle. And Royal Commission, we do submit our GHG inventory. And we have also GHG workshops. And CAPSAR, the King Abdullah Petroleum Studies and Research Center, we have the Circular Carbon Economy database. And for JIPCA, we have the annual GHG metrics. So I think you have seen the previous graph before. This is just like the reverse of that. But HADA, this is a forecast. So right now, Sadara has employed another consultant to do the Sadara decarbonization study. And for us, internally, we made a couple of forecasts based on the areas that we need to improve. So you can see here from energy efficiency, we have identified like 16% of that will probably be improved. From the emissions control, this is the CCUs, the blue hydrogen, the green hydrogen, so on and so forth that you have seen earlier. And renewable energy, you also have seen that. Offsetting programs, this is technically buying some carbon from other countries, if you will. So that will make up our net zero carbon by 2050. And yeah, I think last but not the least is the assurance and decarbonization plan. We have the annual assurance of the GHG data. We do that to make sure our methodology is correct as per the AA 1000, I think. And then we have the decarbonization study to meet the net zero 2050. Thank you so much for your time and attention.
Thank you, Mr. Al-Astraf. Our last presentation before we take our first break. Mr. Akram Rakban, Control System Engineer at Saudi Aramco, is going to talk about plant web optics analytics. Please help me to welcome Mr. Akram.
هذا صح؟ لليمين صح؟ Thank you, PNCSD and ISA for this conference, and thank you all for attending. It is our pleasure to stand in front of you today to share with you the subject. But before we jump into the subject, there is something strange in the screen. Can someone spot that? The date, October 23rd, 2021. Does it say something to you? Exactly a year ago from today, this day has witnessed the launch of our Crown Prince, His Royal Highness Mohammed bin Salman, long ambitious initiative to reach net zero emissions by 2060. Furthermore, in the same day, our company Saudi Aramco has announced their ambitious plan to reach net zero greenhouse gas emissions throughout the company's operations by 2050. I think the conference day was perfectly chosen by PNCSD and ISA. It can't be a coincidence. Immediately after the announcement, all Aramco departments have started working in this idea in different ways. In the northern area oil operations, we have started the use of digital transformation towards net zero. We have evaluated a couple of options to start with. And finally, we have decided to move further with the first pilot project using the plant web optics analytics from Emerson Process Management. There were three main reasons for choosing this application. The first one is that this tool can be used as an energy consumption advisor. The second reason was that it can be used as a root cause analysis to trace the bad actors. And the third and the main reason that this tool has the capability to help reducing gas emissions. So how are we going to do that? That's what we are going to be discovered during this presentation. First thing first, who we are and what's our role in Aramco. I am Akram Ragabani, Control System Engineer, and I have my colleague here, Radwan Jabir, a Senior Control System Engineer. We are from the Northern Area Technical Support Department, supporting the Northern Area Technical or Northern Area Oil Operations, starting from Qatif area up to Safaniya to Tanajib, near to Kuwait borders. When we say Northern Area, we're talking about onshore and offshore facilities. So without going further in details about NTSD and what we are supporting, because we are not here for that, let's jump directly to the main subject, which is the plant web optics analytics. So how did we end up there? In Qatif plants, we are facing multiple issues and challenges to optimize energy consumption. We are looking for tools that can help us reaching that. Thanks to digital transformation nowadays, there are many applications that can be managed to achieve our goals in order to optimize and reduce the emissions. So we ended up with the plant optics analytics that can be used as a pilot project for this purpose. Today, we are going to share with you our experience with the challenges, the project itself, and the future vision. As said, there were many challenges that led us to this tool. The first one, how to monitor the energy consumption in real-time basis. The console operator has information about the energy, but you can't directly extract the information from the system itself. You have to put it in calculations in order to get the energy consumption. Therefore, a manual data entry is required. Additionally, are the results valid? Furthermore, how far are we from the KPIs? And lastly, if we are far, where are my bad actors? Those are a couple of challenges that we are encountering in our plants. So in order to overcome those challenges, NTSD and Emerson have started exploring the use of plant web optics analytics. For this pilot, it was agreed to consider the two boilers in Qatif plants, and this project has pre-identified success criteria based on the results of this pilot project. The plant web optics analytics can be deployed in the Northern Area Oil Operation as a main energy management tool and emission reduction application. So in Qatif plants, there are two boilers used as an auxiliary steam suppliers, in addition to the heat recovery steam generators, which are known as HRSGs, to produce steam in order to meet the plant's demand. However, there are always excess in the steam production. Consequently, excess of use in the fuel gas. So the point is that we know exactly how much we had in the steam production just after the fact, while we should know that in advance so that we can avoid this excess steam. Therefore, we have made the following action plan to address that. So our action plan includes 4 steps. The first one is digital transformation of the energy KPIs calculation and visualization processes. This will enable us to monitor the energy in real-time basis. As a result, we can start talking about energy optimization because we have some values to use. In addition to that, in case of deviating from the KPIs, we can trace the bad actors using the root cause analysis provided by the tool. So how does it happen? There are 4 phases in this application process. The following figure illustrates the overall methodology that can be followed in the design of the solution. It covers the entire process from the historical data analysis to modeling to uncovering the knowledge to actionable recommendations. So the first part is collecting the data from the historian in order to build a model. And the data then will be cleaned, clustered, and the model will be finalized, and this will be happen offline. So the energy management information system then will validate the data to detect and predict abnormal conditions, execute real-time calculation of the key performance indicators, as well as root cause analysis in case of deviating from the KPIs. So the outcome of the energy management information system will be presented to the user in a graphical presentation or representation. In general information as well as in detail information about the energy KPIs and the emission and the bad actors as well. So how have we applied those phases in Qatif plant? Based on the historical data, a model has been developed to calculate the efficiency of the boiler. Normally, this process happened manually by collecting the data from the operator or the PI system, which is known as the plant information system, then using the manual calculation method to extract the energy information. Now this manual process is digitally transformed by calculating the boiler performance using real-time data from the DCS directly and presenting it to the user in a dashboard, similar to what you are seeing here. So this digital transformation helped us to closely monitor the energy consumption. Now we can use the real-time steam demand from the consumers, the boiler's load, as well as the steam margin that can be used in case of increase of steam demand. As you can see here from the figures, you will have an idea about how much you can increase the demand for each boiler. Also, the KPIs are calculated in real-time basis, and this will help to detect KPIs deviations in early stages. Now, we have the full picture of energy consumption and the boiler's load. We can start thinking on how to optimize those items to avoid KPI deviations in early stages. So how we are going to do that? The load advisor application will calculate the steam load for both boilers in real time based on total demand required by the steam consumers. The advisor will come up with the load advice such that only the demand that is not met by the heat recovery steam generators would be fulfilled by the auxiliary boilers. The boiler load then will advise through the advisor application to continuously monitor the total steam production and consumption, and based on the surplus or shortages of the steam, it will calculate the suggested load for both auxiliary boilers. Also, the load advisory will advise the load percentage for both boiler, which will be displayed as a message in the application dashboard. This will be served as a guideline to the operator to take the necessary action to start, stop, alter the load for the two boilers. Similarly, if there is a reduction in a steam demand or consumption, it will result in excess steam, and the advisor will recommend the operator to reduce the load of the two boilers accordingly. So while doing that, the advisor will read the efficiency of both boilers, calculated through the EMS or the energy management information system and the backbone of the logic. And then, according to that, the load advisor will prioritize the boiler with the highest efficiency first, while assigning the auxiliary demand to the boilers. So if the auxiliary demand is more than the maximum capacity of a single boiler, the advisor will assign the additional load to the other boilers as well. Finally, we have the fuel gas saving. So at this stage, the advisor has assigned the tasks to the boilers based on the steam demand. So the difference between the actual steam flow and the advised flow for both boilers is a potential steam saving. And the steam saving can be easily calculated based on the demand and produced steam. Hence, it can be used to estimate the financial saved value in the US dollars. Now, we know our KPIs and we know how to optimize our consumption. Theoretically, we shouldn't deviate from the KPIs. And because we are not in a perfect world, we will somehow and sometime deviate from the KPIs. In this case, we need a tool to trace the bad actors causing this deviation. Here comes the root cause analysis to act. The first thing that the root cause analysis will do is that it will diagnose the energy performance continuously. Then if any of the KPIs violates the target, a flag will be raised. After that, the RSA then will automatically activate the fault model propagation in order to identify the real root cause among all possible causes. After that, the model will identify the equipment responsible of the detected deviation and then pinpoint the bad actor. And finally, once the bad actor has been identified, RSA will be presented in a message to the operator for the guidance to do the necessary actions. The project has been initiated in the fourth quarter of 2021. The engineering phase took place in quarter 1 and quarter 2, 2022, and we are expecting to commission this project in December 2022. So where we are now, we are on the final stage of the testing model. And once the model has been commissioned, it will be kept under observation for around 3 months to satisfy or to checklist the success criteria that we have identified through in the beginning phases in the early stages of this project. And once the so in the future, once the success criteria has been met and the recommendations provided to the console operator are making sense, the next phase will be to make the corrective action as far as we can. In this case, the boilers and load sharing and the switching between 4 boilers based on the calculated efficiency for both boilers. Additionally, as we have optimized the steam consumption, we have indirectly optimized the fuel gas consumption as well. Optimized fuel gas consumption means less release of gases to the air. So in this way, we are going to reach emission reduction that we can calculate or measure on later stages in order to confirm emission reductions. Now, please welcome with me my colleague Ridwan Jabir to the stage. Any questions? Yeah. I think there's one there. Okay, go ahead.
Yes, hi. Thank you, Akram. That was really brilliant. And at the end, the futures for an autonomous, optimized energy consumption, that is just brilliant. Now, the gas boilers, as far as I know, they are 60% efficient, and the target in here is to increase the efficiency. Do you guys have a calculated improvement of that efficiency? Is it like, would you say it would probably increase it to 80% efficiency level? That's my question.
No, great. Thank you for the question. In fact, actually, we don't have that efficiency. We are trying to calculate that based on Excel sheets. And this information is not that accurate to say whether it is 80% efficient or 60% efficient, due to the fact that we are always going to do calculation after the facts. This measurement, once you are reading that and then you are measuring that and calculating that automatically using the digital transformation, you will have the, let's say, let me call it, a daily efficiency monitoring, which will help you to understand how far are we from that efficiency. We cannot say right now, as we speak, because we don't have that in this project, we are going to commission that in December. We cannot say that we are now at 80% or 60%. It is unknown unless we commission that and then we see the data and validate that based on the calculation that we usually use. Does that answer your question?
Yes, brilliant. Thank you. Appreciate it.
Okay, thank you. Thank you so much.
I think there is another question there.
Show what is allowed.
Okay. All right.
Very much, Mansoor, with you from SETOR. I have a question with reference to you mentioned about boiler efficiency, but correlation with NOx, oxides of nitrogen. Is there any correlation which you are making to assess in the stack and to compare with the efficiency of the boiler?
If my understanding question is that whether we take the efficiency of the boiler itself in consideration, is that correct?
Yeah.
Okay, great. Now, this tool, what we are taking into consideration is that we have two boilers, and of course we know that those two boilers are not ideal. The efficiency of each boiler is different, right? This tool is, let me say it, smart enough to identify the efficiency of each boiler. And then once we want to start a boiler, we always select the boiler with the most efficiency. If that boiler is meeting the demand of the steam, then we are done. We are keeping that boiler running. However, if the demand of the steam is higher than the capacity of the boiler, of one boiler, we take the boiler with the most efficiency, with the highest percentage, to be taken into consideration operation, and then the second boiler, which is less efficient, will take a small percentage just to take the extra requested demand for that. Yes, we are taking the boiler itself efficiency in consideration, as well as two boilers together as a total efficiency of the system.
I'm not sure I think on top of what my colleague has said, you mentioned something about the nitrogen oxide, right?
Yes.
Yeah, it's okay. It's gonna be as a result of the combustion, and it will be released through the exhaust stack. However, what our goal is, once we reduce the fuel gas and we know our demand for each plant and we don't have excess steams, as a result we will reduce such the CO2 and the NOx as well going to the stack. So if we know what we are measuring right now, then we can optimize it even further.
Yeah, I think you consider during will be helpful for you.
I couldn't hear the last sentences. Can you please repeat it?
Actually, if you will be having efficiency of the water.
Okay, well noted. Thank you. Thank you so much. Looks like an interesting subject. If there's any question, we can meet in the break, can answer your questions, and
one more question?
Oh, we can. For later question we have on the break, we can visit us in the exhibition to ask all the presenters any other questions. So before we go to our moment that we're most of us waiting for, the break, we would like to have a moment of recognition once again for our guest speaker. So I would like Dr. Abdullah Falahi to come up to the stage to recognize the speakers. First, I would like to invite Mr. Scott and Ms. Ghufran to the stage. Second, Mr. Muwaffaq Medani. It seems people, they were heading to the break. Okay, Mr. Al-Asraf Ibing. Okay. Yes, Mr. Al-Asraf. And lastly, Mr. Akram and Mr. Ridwan. Mr. Muwaffaq, we catch you again, so please come to the stage. With that, we conclude our first session for today. Please feel free to visit our exhibition to the left, as well as to enjoy some refreshment at the back. We will be continuing our next session at 10:45 sharp. Thank you. عنده تعديل في السلايد بس في ديت بعدله في الافترنون اي 3 اعتقد لا 3 يس حسان طريقي ثاني واحد
تست تست تست. في عندي فيديو بالاخر. هلا بالفيديو فيني احكي اوفر. تست تست. ابعد لي شوي صغيرين على النص.
معلش الوقت والله مشى الوقت شوية ف we have to adjust the try to make comments here and there. توفيق إن شاء الله.
Just to make sure I know how this is working. So left is to go next. Right is to go back.
I think the right is not working.
How do you go back? How do you use the mouse?
Let's make sure that we won't miss any slides. Forward.
looking at condition-based monitoring to predict when the performance of the meter goes outside acceptable limits.
Is it the keyboard shortcut like Control L, so you can have the virtual data point there? Yeah. And then your mouse is kind of like a laser pointer here. This is the so it shows. Oh,
Oh, yeah.
okay. But yeah.
So it's on the so what happens? I won't be present.
You also had microseconds. Yeah, that's like the text is a bit overlapping. Fonts. I don't know. This looks very different than like it. Yeah, it's correct. I was using the template language. I can use this as I'm a bit currently standing here, so probably. Yeah. All right. It seems to be working. You took the technology risk and you had all these animations and videos. So yeah, good luck. All right. See you soon. ما انا هستعمل هيدا.
عبد الرحمن حماد الله يبارك فيك. I'm the next moderator. Your presentation is okay?
بدي اوصف فيه الايفنت، بدي احط الاوبننج تبعك، يعني فيك تبعت لي الرايت تايب تبع الاوبننج لانه بدي احطها يعني تكون هي الاساس تبع الارتكل. ضبط لك اياها مظبوط. الله يعطيك العافيه. You will always do. هنا في صراحه شوف هنا في flexibility للنتورك We started this journey يعني society وكل شيء. ايه كمان ايه حاول انك تبعد عن mentioning مثلا الا اذا كان بتقول مثلا
Ladies and gentlemen, we're about to start in 3 minutes. Kindly take your seats. Thank you. Your Excellencies, ladies and gentlemen, good morning. I hope that you enjoyed your break. My name is Abdurrahman Al-Hammadi, and I'm going to be the moderator of this segment of the conference. A gentle reminder of the housekeeping rules. Please ensure that your mobiles are on silent mode or completely switched off. In case of emergencies, please evacuate through the nearest exit or fire escape, which are marked with a green light. We have one in the back and two on the sides. With that being said, let's continue our growth journey with our next speaker. Our next speaker is Mr. Wasim Ghadban. Mr. Wasim is Vice President of Global Innovation and Digital Engineering at Kent. His presentation is going to be about asset digital threat versus digital twin. Please help me welcome Mr. Wasim Al-Ghadban.
Assalamu alaikum. Good morning, everyone. So my name is Wasim Ghadban. I'm the Global Vice President for Innovation and Digital Engineering at Kent. Today we are going to talk about the digital solutions and innovative solutions to achieve net zero. We know that there are many solutions, right? We need to use the benefit from emerging technologies, fourth industrial revolution technologies, really to achieve all of these goals. When we are talking about the achieving net zero and sustainable future, we have to be clear that definitely we are not stopping oil and gas production. It doesn't mean that we are stopping oil and gas production, the natural resources, but yes, it means that we have to improve the oil and gas industry. Improve by applications of digital and emerging technologies, the improvement to be more efficient, whether we are talking about design or talking about the construction of our plants and operations. And recently, the World Economic Forum published an article about the value of digital technologies to achieve net zero. So 20% of these goals can be achieved by the application of emerging technologies. And you see there, all these technologies, on top of them is a digital twin. And talking about the solutions and how digital twin can help decision makers really to improve operation, to improve this feasibility as well, studies for the new projects, whether we're talking about brownfield and greenfield. So there are many gaps that we can now improve in our industry. There are many rewards that we can achieve in the design, in the exploration, in the operation. So we know in oil and gas, more than 85% is about operation of the assets, and we can achieve really rewards by application of digital twin and digital technologies. We can reduce downtime. During the exploration, we can use AI for seismic analysis. During engineering, we are using now the automation really to reduce the number of engineering hours and eliminate the repetitive tasks. So goals of innovation in our industry is not only about reducing emissions, but also cover the optimization. It covers as well enhancing safety and reducing the cost. Sustainability is definitely an outcome of all of these. And when we talk about this sustainability, it's a big part of our strategy at Kent. So as you see here in the crowded slide, is whether we are like using all these goals for our own operations internally or also in our services to our clients. Talking about Kent, who's Kent? So Kent is a new joining forces of 5 legacies, talking about Kentech, SNC-Lavalin Oil and Gas, Offshore Wind, Atkins Oil and Gas, Offshore Wind, Kent's, and Houston Offshore Engineering. So we have taken this step to merge all expertise from different legacies and really to focus on energy spectrum. When we're talking about energy, and it's whether they are talking about the conventional energy, oil and gas, or renewables, hydrogen, and offshore wind. in digital space, we are pioneers. And we believe we've been very successful because we know the industry. We are from the industry, and we know the challenges of the industry, and we know technology. So it's not about the technology itself. It's about how to apply technology. If you don't understand the challenges of the industry, you cannot apply the technologies very well. And that's why we see today more than 70% of digital transformation programs failed to achieve their goals. Because it's not about the technology again, it's how to apply it. For us, we have a unique offering. We cover end-to-end solutions, the full life cycle. So we work with our clients really from very early phase to operations and decommissioning. Our innovative solutions, we play the role again of a digital contractor, a digital consultant, a digital integrator. So we have solutions that will address the feasibility of digital programs. We develop ROI for our clients. We develop data-centric engineering solutions, smart construction solutions, and the IOC centers. So I'm going to show you like case studies and projects that we delivered successfully to our clients in my presentation. And we are pioneers in everything called a digital asset, whether we call it digital asset or digital twin implementation, remote monitoring, remote control, and autonomous operations. So let's take a step back and describe digital twin. So what is digital twin? Now in the fourth industrial revolution, we are talking about digital twin, we are talking about immersive reality, metaverse, we are talking about analysis. So what is really digital twin and what is the concept? We've heard today many presentations and the value of digital twin that can be, can help oil and gas industry and to capture and to present the data for the emissions. So what is really digital twin? As you see here, there are many use cases for digital twin in different industries. So digital twin is described, the first concept was developed by Dr. Michael Greaves in 2002 and used by NASA for the first mission of Apollo for what-if scenarios. So digital twin concept is really to create a digital representation of a physical asset. So that's the initial definition. Well, we have developed this concept. So we don't need to have a digital twin only for existing asset, but we can have a digital twin also for the asset that we want to build. So before having the asset, we can build a digital twin where we can use all the benchmark and the data from previous experience really to enhance our design. So I'm going to cover today all of these. So digital twin as well used in Google Maps. So did you ask yourself how we get the traffic data if you want to move from one point to another point? It's really by different information and even the devices, the mobile phones of different people on the same street. You can get all these insights. So the Google Map itself is a digital twin for the entire Earth. And you see the development before where we used to move from static information now to more real-time information. So you can see, for instance, the popular times. So it gives me the current status of my destination. And also you can get all other information. You can book, let's say, an appointment directly from the Google Map. In the near future, you are going to use in the GPS and the Google Map, let's say, all the information about signals, about like the parking in the malls. Let's say directly it will give you, if you are moving, if your destination is a mall, for instance, it's connected directly to the parking system and will tell you in which floor you have a slot available. So you don't lose time by like looking in the available slot. So it's a digital twin of the entire Earth. By the way, yesterday Abu Dhabi announced the digital twin, the development of digital twin for Abu Dhabi city. It's not limited to 3D, and also they are going to connect like real-time data. So another form of digital twin is the smart cities. Smart city concept also will help to reduce the emissions. And currently we have the Barcelona, London, Singapore are considered as the most advanced cities, smart cities. We are all waiting for NEOM to come in the picture, and we do believe that NEOM is going to be the most advanced smart city in the world. And this concept, again, is built really to integrate different systems, utilities in one single platform. Digital twin is used now in the autonomous cars. So the concept also takes the information from the environment surrounding the car and also internal information about the performance of the car. So the concept of autonomous operation is built on top of digital twin. Well, don't be scared here. So in the near future, we are going to have a digital twin for each one of us. Not to reduce emissions, but the digital twin is going to be used for for healthcare. So you don't need to visit a doctor anymore because all the information, while you are moving, for instance, your mobile phone can track your move. And if there is any changes, it will directly give a trend about or trigger a trend that there is something to need to be checked. Also the smartwatch that we have. So also the way that we talk, whether we are using the calls, the phone calls, or all of these. So this is coming. That's also the future. The future just started. And the metaverse that we are talking about is really to create a virtual representation with real-time data of each one of us. So this is what we call the ecosystem. To go back to infrastructure, digital twin is used now for urban planning. It's used as a beam, and it's used also to enhance the design, and we use it as well for virtual reality to improve or also to check the feasibility of the plant before we build it. And digital twin, so you see here there are different use cases. Digital twin is taking a big place in the product fabrications. So once, like when you buy a new phone or you buy a new equipment, IoT equipment, let's take a phone. So always you get this message like, do you want to connect your phone to the producer, let's say Apple, so to help them to improve their product. So what does it mean? Is all these devices, once they develop like a design, they create the digital model, and this digital model, it gets enhanced by all the experience. So every one of us, if this option is turned on, it will feed, in case of any issues, it will feed the original digital model with the experience, why you are having this, what are the conditions, and then they will enhance the software, and that's why we are receiving like this updated version of the software, because it's really reading from all experience and enhancing the main software. So why I included this in the presentation, because this is what we want to use really to reduce emissions. If we have always a digital plant, a master digital plant for oil and gas facilities, and then we can connect all the assets to this master, and then all this real-time information will feed about the emissions and when we cross the boundaries, so we'll be able to enhance our design. In oil and gas industry, a digital plant and digital twin and digital thread is a big topic, right? First, because we deal with real-time data. Second, because we deal with full life cycle. It's not about only design, it's mainly about also operation. And we are using the digital plant really to bring efficiency for the full life cycle. Is really to be able to use remote monitoring, remote operation, and also achieve the ultimate goal of the industry, which is autonomous operation. I'm going to share with you today the use cases that we implemented for each milestone of this roadmap. Well, let's talk about the digital thread. All the presentations that I've seen today and yesterday is talking about the environmental data and how we capture them from the satellite, and we capture them from robotics and also from the historian, and really improve and share this information, analyze the information and share it with decision makers to take decisions and also to see what can be enhanced. But what we really need, right, there is an area of improvement here, because we need to think out of the box here. We need to think about full asset life cycle. So we need to really to start from very early phase and to be able to capture, like in our design, what is the plan for emission, during construction, the emissions by the contractor, and also in the operations. So this is very important. I'll move here quickly. So the concept of digital plan is really to capture data from different systems and different timelines to be able to build this entire picture of your plant. So it's not only about operation, it's the data that we define in the class library, the data that we capture during engineering, construction, and operation, really to be able to enhance the model. And this is what we see always when we talk about the AD digital plant approach that I developed for the energy sector, is you see here the progressive development of the plant. So we don't need to wait till we have the live streaming environment to capture the emissions. We really need to start from the very early phase. And Aramco, recently we started to implement digital twin and really at the early phase of projects to be able really to develop this benchmark for the digital assets. As you see, once we have this data, it will help me also in the feasibility when I design my asset. Do we really need to proceed from this? We have the data, so it should be a required and mandatory information for each asset, for each system, for each equipment. So following this concept, the AD digital plant, we have identified more than 72 solutions that can be achieved. It's not really about reducing emissions, which is here as a 7th dimension. It's about really enhancing the full life cycle. So out of these 72 solutions, you can select which solution you want, because as we have seen today, there are many use cases that can be achieved by implementing digital technologies and the implementation of digital plan. So based on the needs, you will be able to select the technologies, the processes to be implemented. So it's not just one solution. It's a big list of solutions that will help us to achieve autonomous and unmanned operations. And what we really need, we need an integrated asset life cycle, really that will connect people, process, systems, and tools. So technologies alone means nothing. We need to connect and have an integrated approach in a digital environment. Also, we have developed a process also to, we talk about the aging assets in oil and gas. So we developed this process to be able to capture and also transform the existing assets to more integrated facilities that is suitable for the future. That's how it will help us also to analyze the data and reduce emissions. I included here a few successful implementation and projects that we deliver to different owner-operators, just to show you what can be achieved. So in Aramco in 2019, we delivered this solution at the engineering stage for Berry Gas, where we have saved $2.5 million just at the field stage by implementing like an integrated approach and the heat map and virtual reality for improving the design. Recently, last year, we've been working with Yusuf and Dr. Abdullah in the implementation of digital twin at the field stage as well, really to build this class library and to do the full integration of the plant, of the information, whether from engineering systems and others, really to create this digital feed that will help contractor to understand the scope and really to be able to generate compliance directly from the model. We are implementing the same concept for remote monitoring. So we delivered recently to ADNOC the advanced version of Panorama. So everyone is aware about Panorama, the 52 screen. So we have developed the advanced version using the AI, where we integrated 16 technologies using digital concept, used the AI for virtual flow meter, used all this information from various systems to be displayed in the context directly that goes from the plant level, from the country level, plant level, system level, equipment level, all displayed in one platform. So the digital concept and digital asset is really to create a system of systems and make this information available to the right team at the right time. Currently, I'm leading a project using the same concept, but this is also a step further, is for remote operation. the first of its kind. Sorry, I should go back. So the remote operation for ADNOC Al Nasser is where we are going to transform this facility, Al Nasser, the full unmanned facility. Currently, we have 120 employees there. So it will be remotely controlled from the main office, like 185 kilometers far from the offshore plant, and using the same concept that will reduce also the emissions and the carbon footprint. Also, in the Total in 2017, we used the same concept for immersive training. So there are different solutions. Since we are running now of the time, so I'll conclude here. I'll just play the video, just 1 minute if you allow me, that will really give a full picture about integrated asset life cycle for engineering, construction, and operation. Thank you.
Thank you very much indeed, Mr. Wasim Ghadban. Our next speaker is Mr. Philip Anthony Mark. Mr. Philip is a technical advisor and consultant at Arabian Calibration Company. His presentation is going to be about flow meter condition-based monitoring and its role in achieving net zero emissions. Please help me welcome Mr. Philip Anthony Mark.
I wish if I want to walk around. Thank you. And the mouse. Good morning, everyone. Can you hear me okay? Yes? No? I don't know how to change the volume, so someone will have to do that for me. Good morning. My name's Phil Mark. I work for Arabian Calibration Company based here in Saudi Arabia. We are proud to have Saudi Aramco Wahed Ventures as one of our principal shareholders, and we're also supported with our technical partner Tufsud National Engineering Laboratory, who some of you probably will know of as the NEL based in Scotland. What I'd like to do today is talk about something that's quite different to, I think, many of the other presentations. Lots of the other presentations have gone into the details of how we can minimize greenhouse gas emissions, how we can reduce emissions into the environment, into the atmosphere. What I'm going to look at is, go the right way, look at the mass balance or the net zero balance itself, because that balance is made up of a series of measurements, typically using flow meters. But what happens if that measurement isn't correct? The balance that you get won't be correct because you've got an incorrect reading from your flow meter. I think I've jumped on the slide there. So we're looking at flow meters, and the flow meter will be selected for the application, the operating conditions. Importantly, it will have an associated measurement uncertainty or accuracy associated with it, and that uncertainty will then feed through into the overall net zero calculation. Now, when that flow meter is first installed, it will be calibrated, ideally by an independent calibration facility, and so the performance of that flow meter will be known over its operating range within certain limits. So it will have the uncertainty associated with its performance. And then the ongoing performance of that meter will be established by regular recalibration. I was brought up in a time when presentations were based on overhead transparencies, and so pressing the buttons sometimes can get a little bit confusing. So apologies for that. So we talk about calibration, and the calibration is there in order to maintain your confidence in the readings that you're getting from that flow meter. If you're not confident in the readings, then there's very little point in taking those readings. So it's all about confidence of measurement. And traditionally, the period of time between recalibrations was based on a number of factors. That could include the importance of the measurement. I know in Aramco there are certain meters, custody transfer meters, which have the potential to be calibrated every single time they're used because they have a dedicated pipe prover. Also, it's based on the stability of the meter or the drift. It's based on operational experience, based on a whole range of factors. So, but it's traditionally time-based. So after 1 week, very short term, after several months or a year or more, the meter will be recalibrated to give you confidence, the ongoing confidence in the performance of that meter. But the question that we need to ask, if you're carrying out a net zero balance on a regular basis or an ongoing basis, are you confident that the values that you're putting into the net zero balance from your flow measurement systems, are they still correct when the meter is operating in between its calibration frequency? What happens if something happens to that meter during that calibration frequency or between calibrations that causes the performance of that meter to change? What you may have, you may think that you've got net zero. So you take all your measurements in and you do the calculation and the emissions equal the quantity that's captured. So net zero. But the reality could be that because of mismeasurement, because the meter has shifted in performance during its calibration cycle, you actually have either a positive set emission or potentially a positive capture from the system in reality. So, how do you confirm the performance of the flow meter during or whilst it's operating in between its calibration cycle. Now, I think it's probably safe to say that all flow meters provide some level of diagnostic information. And this can range from very, very limited, as in the case of some of the mechanical meters, to almost overwhelming in terms of the current modern electronic meters such as ultrasonic and Coriolis. I remember a time not that long ago, probably in the early 2010s, where we were talking to an operator who'd recently installed an ultrasonic metering system for their gas measurement. And he said, "This is really good, it's giving me lots and lots of information," and he showed the screens of all the diagnostic information that was available from that flow metering system. But he said, "There's just so much information here, I'm overwhelmed." And what was even worse was, as well as having lots of information, there was no correlation between what drift in a certain parameter meant in terms of the actual performance of that flow meter. So what happened in reality was they didn't even bother with the diagnostics. They didn't look at the diagnostics because there was too much information, and that information didn't mean anything to them as an operator. However, we can see there that if there is information available, providing you can correlate a drift in a diagnostic parameter with some real event that can affect the performance of the flow meter, then you've got the basis for condition-based monitoring. So you can continuously monitor the diagnostic parameters and assess what impact that is having on the measurement performance of the device. By the end of the presentation, I'll work out which is the right button to press. So this just shows it in very simple graphic, and I must admit I do have presentation envy from the previous presentation. The graphics there were incredible, and this is a little bit low tech, I'm afraid. But it serves to show that traditionally you calibrate a certain period after a meter is installed. Regardless of what's going on, you continue to calibrate at that frequency. But I think the interesting thing to look at is in the box at the top right, 60 to 70% of mass flow meters that were sent to NEL for recalibration at their set frequency didn't require adjustment. Their performance was within the expected operation for that particular device. Now, equally, that means that between 30 and 40% did require adjustment. The original driver, I think, perhaps behind condition-based monitoring was to offer operators the opportunity to extend calibration frequency. Rather than calibrating every 6 months or 12 months, to look at the performance of the meter in real time and allow you to push that calibration out to 18 months or 24 months, or whenever the meter told you that it required calibration. So that had the potential to save costs, because calibration isn't cheap, and particularly when you look at shutting the system down or taking the system offline, sending the meter back to a calibration facility, that can add significant costs. But if we flip that condition-based monitoring around, we can use it to say, is the meter still performing within the set limits? Is it giving me confidence in the measurements that I'm making, in the measurements that I'm feeding into my net zero balance? And so by using condition-based monitoring, we can actually monitor the performance of the meters and ensure that the balance is correct. So if we look at the digital services in brief, on the left-hand side, your left, yes, we're looking initially at data visualization. This is really just taking the data from the field, the historical data, and sifting it out so that you can see key things that are important to you as an operator. Where it becomes more interesting, and really the focus of this presentation, is where we're looking at data analytics and fault diagnostics. And we'll go into a little bit more detail in the following slide, but really that stage is looking at linking changes in diagnostic parameters to real events that are occurring in the system, real events that are being seen by the flow meter. Once you've been able to establish those correlations and those linkages, you can then move to remote monitoring or condition-based monitoring, where the information coming from the flow meter tells you whether you can trust that value or not. If you can trust the value, you can then use that for whatever purpose you're looking for. In this case, achieving net zero or being confident in that net zero figure. Equally, it will tell you if the meter is performing outside its expected tolerances, and therefore you need to do something to bring it back in line so that you can have confidence in the readings. The next stage from condition-based monitoring is actually to use machine learning to predict when the flow meter will start to go outside of its calibration parameters. So, in terms of the data science, this is the path that the data scientists follow. But I'm conscious that we don't have a huge amount of time, so I'll flick on to more interesting slides. The first slide, or the first on the left-hand side, shows the dashboard. So it's presenting data in a form that is immediately apparent to the operator. But it's not really what we're looking for here. We're looking for the next one, diagnostics, data and analytics. And this is where we take real data from the customer, from the end user, from the operator, and we link that to real events that were happening in the field. That's the start of building that linkage between the diagnostic parameter, changes in diagnostic parameter, and an event that's happened. And more importantly, or in parallel to information from the field, you can also start to build up this information in the laboratory. So you can take a flow meter and you can subject it to known disturbances or known influencing factors and see what happens to the diagnostic parameters. And in that case, you can start to build up a very clear correlation map, and we'll see in the next slide what a typical correlation map looks like for a Coriolis mass flow meter under a given set of disturbances. So with the diagnostics, with the data analytics, we've been able to rank the importance of the various diagnostic parameters in terms of a given disturbance or a given event. Right, I shall skip forward to the important slides, or skip back to the important slide. Perhaps one of the most important slides is, or images, is this one here. And that is a heat map or a correlation map. And for a given disturbance, a given influence, that shows the correlation between the various diagnostic parameters when that disturbance is occurring. The red colour, the dark red colour, shows a strong positive correlation. The dark blue colour shows a strong negative correlation. But it's through building up those patterns, the data scientists can start to build the models that will then predict the performance of the meter. What I'll need to do, because I think I've got 2 minutes left, is flick to perhaps the really interesting slide. This is for an ultrasonic flow meter. And the ultrasonic flow meter was installed in the facility at NEL and subject to known disturbances. So it was installed under ideal conditions. It was installed with both horizontal, vertical mismatches and also a step change on the input to the flow meter. And all of that information, the diagnostic information for each of those instances, we created a correlation map, and that was used to build the model for that flow meter. And similarly, we carried out the same series of tests where we introduced waxing to the internals of the meter and again monitored the diagnostic parameters. So from that, we were able to build up models that could predict the performance of the flow meter based on the diagnostic information. We then ran a series of blind tests where we introduced a disturbance, but the model was seeing this data for the first time. So it was a true test of the validity of the model. Could it predict, from the diagnostic information that was being produced, could it predict what was happening inside the meter? And we can see from the various figures, the probabilities of the event being correct, that it was pretty good. Worst case was 82% probability that it was a step change, when we knew that it was a step change because we'd introduced that. When we're looking at waxing of the internals of the ultrasonic meter, we could see in all cases it was 100% probability that the model correctly predicted what was happening inside the flow meter. Now, if you can predict from the diagnostic parameters what is happening within the flow meter, you can then take that next stage, take that next step, and use that to predict whether the measurement uncertainty for that flow meter has exceeded its accepted tolerances. If it has, then it calls into question the confidence of the measurements that you're making, and if you're using those measurements to calculate your net zero balance, then it calls into question that complete calculation process. So it drives you to making sure that the measurements you're making are correct. Sorry, I think I've run out of time. So in conclusion, let me think of the conclusion. The conclusion is that certainly the modern electronic type meters, Coriolis, ultrasonic, have vast amounts of diagnostic data. That data is very difficult to interpret just by the operator themselves without the support of machine models. But we know from the tests that we've carried out and the work we've done back at NEL and supported by ACC here in Saudi Arabia, we know that we can link the diagnostic parameters to real events inside the flow meter, and by doing that we can give everyone the confidence that the meter is correct and that the net zero balance is valid. Thank you.
Thank you very much indeed, Mr. Philip Anthony Mark. Unfortunately, there's no room for questions. You can ask the speakers during the break. Moving to our next speaker is Mr. Amjad Al-Khater. Mr. Amjad is an engineer at Saudi Aramco, and his presentation is going to be about global manufacturing use of technology towards environmental sustainability. So please help me welcome Mr. Amjad Al-Khater.
Thank you all. Good morning. I hope you're having a wonderful time at this event so far. My name is Amjad Al-Khater. I come from Saudi Aramco, the Global Manufacturing Support Department. And it's my pleasure today to take a little time to tell you about what we're doing to improve environmental performance using digital technologies. So I'll start my presentation with a brief introduction. And I realize I'm already putting some weird terms on the screen like IMOMs, but I'll explain what that is in a second through the overview. And then we'll go through an overview of the environmental management solution that is part of IMOMs. And then we'll have a brief preview of the environmental dashboards that we use to track environmental performance. And we'll go to the conclusion. So within Saudi Aramco, we look at environmental protection as a fundamental and long-standing focus area. And we continue to implement initiatives and follow increasingly stringent regulations with the aim of minimizing our environmental impact. So what we're doing here today is no different. It falls in line with the company and with the Kingdom of Saudi Arabia's aspirations towards net zero. And those are coming within 3 pillars. So one of them is economic diversification, the second one is digital transformation, and the last one is environmental protection. And so I feel the need to at least touch on Saudi Aramco's digital vision, which is to become the world's leading digitalized energy corporation. Next to that, we have our net zero strategy within global manufacturing. And just by looking at it, what you'll find is that we've embedded the digital vision within our net zero strategy. And so the key here is to leverage technologies in order to meet the net zero strategy. And I want to emphasize that it's only in a small part, but also in a big part. So that brings us to IMOMS, the Integrated Manufacturing Operations Management System. So IMOMS is bigger than our net zero strategy, and it has a lot of factors coming to it. But basically, IMOMS was introduced within global manufacturing to capitalize on the generational shift in technology and offer a set of advanced, automated, and integrated solutions that contribute to a plant's journey towards full digitalization and achieving operational excellence. So the aim here is to deliver best-in-class production, reliability, safety, and environmental tools. So to explain about IMOMS in a deeper terms, typically in our manufacturing facilities, we have plant equipment, and those plant equipment are typically equipped with instrumentations and advanced process controllers. And through those instrumentations, we collect a lot of data, and we process that data using the manufacturing operations management level, which is basically the Excel sheets, the Word documents, the emails, reports, checklists, etc. And based on the analyses that we do in the manufacturing operations management level, we make the very important business plans and logistics. So we found here an opportunity to introduce integration. And integration will allow all the different disciplines to communicate with each other to solve complex issues and enhance collaboration within the facility. And so we've designed IMOMS based on the International Society standards, ISA 95 standards, and this provides us with 5 functional areas. So we have production operations management, inventory operations management, quality operations management, reliability and integrity management, and regulatory compliance management. And the main idea out of these 5 functional areas is to provide the right user with the right information at the right time to make the right decision. Each of those 5 functional areas is made up of different solutions, so we have over 15 solutions within IMOMS, and the main outcome of IMOMS is what we call the one-stop shop platform. So each user will get one dashboard based on their role, and this dashboard will contain all of the information that they need without them having to go after the details and try to track down this information. And so, tying it back to the subject of environment, with early industry references, we predict 10 to 15% reduction in hydrocarbon losses, 15 to 20% reduction in environmental incidents, and 20 to 30% reduction in air pollution rates. So let's dive a bit deeper and see how that would be possible. So we'll go through our environmental management solution, which is under regulatory compliance management, as I'm sure that you've put together. So looking at regulatory compliance management, it is simply defined as a collection of activities that manage environment and safety to reduce risk and improve performance. So here we have 2 components. One of them is the process safety and operational risk management. The other one is the environmental management solution, which is the focus for today. But both of these solutions combine to minimize risk, enhance safety, increase the effectiveness of activities related to the environment and safety, and enhance environmental performance. Now, looking at the environmental management solution, it is a solution that's meant to help users achieve maximum compliance to internal and external environmental regulations and achieve operational excellence. And this is done by placing intelligent controls in the form of rules, alerts, and notifications. So in basic terms, what the environmental management solution does is basically emission monitoring and reporting. So it is visualizing all the environmental related information, and this results in reduction of manual work within data collection and generation of reports. And it highlights the compliance status to help users achieve the maximum compliance. and this is done in real time so users can act proactively. And then it also has built-in tools to auto-identify any exceedances or environmental deviations and allows the user to investigate and correct the deviation. So we have 5 modules under our environmental management solution. So we have emission monitoring, water and wastewater management, hazardous waste management, environmental performance tracking, and environmental incident investigation. Some of these are further broken down. So under air emissions, we have stack emission, and this is including greenhouse gases, but also criteria emissions like SOx and NOx. So we have both continuous and predictive emissions. We also have fugitive emissions management and ambient air quality management, and we have flare management as well. And then under water and wastewater management, we have industrial wastewater, groundwater management, potable water, and seawater. And the typical process that we follow, or the scheme, is to first establish the boundaries of the facility, and then identify which equipments within the facility are impacting the environment. So we look at equipment which is impacting air, equipment which is impacting water, waste, and so on. And then we ensure that we are collecting enough information from these key equipment, and we have the right standard-based calculations to identify or measure the pollution rates. How we've done this within Saudi Aramco is we've capitalized on existing technologies like PI, Data Acquisition Historian, which is a tool that collects data from the instrumentation within the field and allows for historical records. We also have SAP, Environmental Health and Safety Management, to track all of the waste information. We have the Laboratory Information Management System to record all of the lab sampling records. And we have blending, movement, and automation to get the tank throughput. And we've added on top of that commercial applications that add new functionalities. So the first one that we have is an environmental, social, and governance performance application. Now this application basically takes care of all of the data collection and calculation and provides the data to the user. We have one more application for predictive emissions monitoring. So this has been explained in this event previously, but basically we collect some parameters from the field and we use mathematical models to get predictive emissions. We also have visualization and reporting platforms, and these collect the information both from the existing tools and the commercial tools and deliver the information to the user. And so the typical process that happens is, first one is the collection of data, which is usually coming from PI or lab. And then we take that and we put that in our new commercial tool where we have pre-configured equations and calculations that need to be performed. Those calculations are performed, and based on the configured targets and limits we have within the system, it will alert the user about any deviations. At the same time, it will visualize this information to the user and allow the user to investigate in case of any deviations or exceedances. And the last step is to generate the reports, and this can be done both manually and automatically based on the need of the user. Now, unfortunately, we cannot show you a live dashboard, but what I have here is a mock-up that will hopefully give you a flavor of the dashboards that we have in place. So we have the role right on the top, and below we have the main components. In the corner, we have the user detail, and just below that, we have a ribbon that allows the user to switch between different displays. And below, you'll see that we have different visual elements. So we have charts, tables, and lists. And then we are using the traffic light system, so green for good, red for bad, and so on. And so what we have here in the home dashboard are some of the most important environmental parameters. So we're giving the user a flaring breakdown for the whole year, complete with forecasts so they can assess their environmental performance. We also have daily flaring reporting. We have a section dedicated for all environmental emission deviations. And then we have alerts and notifications. Also under quick access, you'll see that I'm highlighting one of the reports. So the user will simply click on this button and they will see a report. And based on the details above, they can adjust the date and time, and they can even specify a particular unit within the plant to see the report for. This is one of the other pages that we have. So again, this is environmental data that's related to water. So we see some delta temperature of return to sea, water discharge quality, and water discharge quantity. And what you'll notice is some of these components will have a report button in the corner. So if you click on the report button, again, so this is for trending, so the user can go back and see a complete historical trend of these values for further analysis. This is another part of it, which is a sneak peek of the mobile dashboard. So it shows, again, a simple view of the major environmental parameters. Now, everything I've shown so far and explained is related to IMOMS, which has been first developed for Jazan refinery. However, our strategy moving forward is to avail IMOMS in the cloud and enable it to be easily expandable across all operating facilities. And this has been a very challenging and gradual process, but it's exciting for us as we envision a new, fully integrated and standardized business line. Now, I feel the need to stress that this is only one part of the grand picture of the net zero. So we still need to look at carbon avoidance, carbon offsetting, and additional business processes and measures to continue enhancing and improving. But this will not be possible to pursue these strategies without first understanding our environmental performance as a baseline. So to recap, IMOMS, when implemented for environmental management solution, allows for these added benefits such as reduction of manual work, real-time monitoring, maximum compliance, timely information, tracking of rules and alerts, auto-identification of deviation, and generation of workflows. Thank you so much for your attention.
Thank you very much indeed, Mr. Amjad Al-Khater. Our next speaker is Mr. Juka Borgman. Mr. Juka is Director of Technology Development at Valmet Flow Control. His presentation is going to be about how does additive manufacturing affect emissions? Case industrial valves. Mr. Juka Borgman, the stage is yours.
Thank you. Thank you for having me. It's an honor to be here, and this is my very first time visiting Saudi Arabia. And I'm very keen on sharing my experiences on the topic that how does 3D printing affect on emissions. I work for Valmet Flow Control, and we are a manufacturer of industrial valves, actuators and positioners. They have been sold under the brands of Neles and Jamesbury. And there's an example on the top right corner from our products. The outline of my presentation is that I will first share you the background and motivation on how I got interested on the topic. Then I will be comparing the conventional and the additive manufacturing chains. I will talk about general emission reduction potential in these manufacturing chains, and then fourth, a special comment on the additive manufacturing use in pressure retaining components like industrial valves, and then lastly I will conclude does it make sense to 3D print components from the environmental point of view. But let's start from the background and the scope of my study. So as a company, we have been 3D printing metallic valve components since 2014. And Valmet is very much for sustainability company. And our sustainability manager came to me and asked that, hey Jukka, since you have been now 3D printing the valve components, so does it make any different from emission point of view compared to, for example, cast component? And I told her that I don't know, but I will find out. And this is how I got interested in the topic. And one remark on the on the scope of my study. So in Valmet we do categorize these emissions from 3 different categories. First is that what is the energy consumed in our supply chain, and secondly, so how much energy is consumed in our own manufacturing operations. The third box is that during the use phase of our products in our customer sites, such as the valve on the right-hand side. But my presentation focuses in these 2 first boxes. So how much energy is consumed in our supply chain and in our own internal manufacturing operations if you either use a cast component or if you then manufacture the component by 3D printing. This is a literature study, but as a benchmark I have been using the 3D printed on the right-hand side. So this is a valve that we actually made by 3D printing, and it was shipped to our customer, and now it's being field tested at the customer site. Good. Let's see and compare the manufacturing chains of either a cast component or 3D printed component. And I'm quoting here a study, a research paper which were made from aircraft components. But it all starts from the mining and from a mine. So you have to get the metal somewhat out from the mine. And in our case, it's stainless steel. So the route starts here and it goes to stainless steel and probably ends up in the ingots. So a chunks of stainless steel that is then later delivered to a foundry. If we would be preparing material for 3D printing, so the same stainless steel would be then transferred to a powder through a process called atomization. But then basically, in this case, we would have this raw material ready for component. Either it's stainless steel ingots or it's stainless steel powder. And in this case, the metal has been melted roughly once in each case. Then we would be ready for the second part of the section in the manufacturing chain, which is then the actual, either the component will be cast if you use the traditional method, or it would be 3D printed if you would take the additive manufacturing route. And in this very conventional manufacturing, so it is first cast, and then it is machined by milling and turning. And in this additive manufacturing chain, so it is the valve body is actually 3D printed, but after that the milling operations and the machining operations are pretty similar as in this traditional route. And this is now an example of a valve body after 3D printing. And you can see that there are certain support structures here which wouldn't be needed in the cast version, but also the cast version will have these feeders. So both have some extra material, excess material on the valve body. So all in all, if you think about these 2 phases, resource production and then this manufacturing, the material has been melted once here and then once again here. And to my eyes, if I was thinking about how did we 3D print the valve body and a traditional casted valve body, so the differences are rather small. In the blank production, there might be like the efficiency or scrap rate of this atomization might have some impact, but also during casting, so they will generate some excess materials, and there is a certain scrap rate in that. Also in the machining phase, so in this 3D printed case, to get rid of these support structures is an extra phase, but considering the big picture, it's not a big difference compared to the traditional manufacturing way. Do pay attention to these two phases, this resource production and this manufacturing, since though I will be zooming in the more details in the next slide. So the resource production was when we produced raw material for the components, so either from the ingots or the powder, and then this would be then machining the components so that they would be ready for assembly. All right, let's now zoom into those two phases. And I'm again quoting this same source, and they made a study with 5 different components for an aircraft. And each component, they have 2 bars. The left one is representing the energy used in this conventional manufacturing. And then the bar next to it, so this is the same component used when it was additively manufactured, so 3D printed. And as you can observe, in all the cases, so the left bar is much higher, so the conventional manufacturing is consuming much more, in the first component, even much more energy than this 3D printed one. It's the same trend in each of these components, so you could really say that using 3D printing will consume much less energy, and though consuming or creating much less emissions during manufacturing. But then if you look at these blue bars, so the blue bar is representative of the resource production phase. So either when you create the material for the component. And we can see that the biggest reduction is actually coming from the blue bar. And the reason is that if you look at this component, so this is not exactly the same component which has been conventionally manufactured or 3D printed. So the geometry has been modified, and they have done something like this. So on the left-hand side you have the conventional component design, but because of the 3D printing, you can do certain optimizations on the geometry and reduce the mass. And this is now the key why 3D printing is causing less emissions. It's because it's using less material. Okay, and now if you now think about valve components, so there's on the top right-hand corner is a typical cross-section of a ball valve. And the valve is a pressure vessel, and our design is very, very much dictated by so-called design codes like ASME and also the material standards. And it pretty much means that if we want to make a stainless steel valve body, which is the heaviest component in the valve, so we just look at from the table that how thick the wall has to be. The same goes for the flanges, so the flanges are standardized. So if we would like to redesign the valve body for 3D printing, basically there's very little that we can do. All the wall thicknesses, flanges are coming from standards and design codes. In the internal parts, we have much more freedom, but on the other hand, the mass of those internal parts is much less compared to this to a valve body. So in valves, we are pretty limited at this moment regarding on 3D, what we can do for design for 3D printing. One note regarding these restrictions, so the standards are evolving as we speak. So last year this ASME released this kind of report recognizing that there's a certain possibilities of using these certain 3D printing methods like laser powder bed fusion, but still the status is that additive manufacturing in valves, it's a kind of very special and slow and expensive way of producing the parts. To conclude, 4 key takeaways for you regarding my presentation. So first one is that the biggest impact on emissions that you can do is that to reduce the mass of the components. So that means that you have to redesign the components for 3D printing, and this is how you are able to reduce the emissions. Secondly, a special remark regarding valves, or any other pressure retaining components. So currently, the design codes and standards, they do not recognize 3D printed materials as such, and that's why we are currently limited on our design freedom. But over the time when the ASME and other standards will be developing, I'm looking forward for the times when we will be able to better optimize our designs for additive manufacturing valves and thus reduce emissions. The last topic is probably most interesting to me personally, since in the beginning I was telling you that my presentation focus is either in the Valmet supply chain or internal operations, where we talk about energy consumption. But the third box, which is now, while many of you are actually using our valves in your production facilities, so in addition to energy consumption, we start to talk about fugitive emissions as well. And this is a very interesting topic, since in 1980 EPA made a study according to which even 50%, so half of the so-called packable fugitive emissions are coming from valves. That's a huge amount of fugitive emissions. I'd like to remind you that that was back in 1980s. I'm confident that currently this is not the case, but it is just emphasizing the fact that if you do not manage the fugitive emissions coming from valves, there's a potential that the emissions could be quite big. And then, like personally, the most interesting thing what 3D printing can do for emissions, this is one laboratory result from 2 weeks back. We have a process in Valmet where we do study ways of improving the fugitive emissions from our valves. And if you are familiar with the ISO standard, which is then related to fugitive emissions, so it's 15848. So we were able to meet the very tightest AH emission class with the tightest CC3 endurance class with the help of a 3D printed performance component. So this is where I think that the potential for 3D printing really is. It's during the use phase of industrial valves in the field. And with this, I would like to conclude and thank you for your attention. Thanks.
Thank you very much indeed, Mr. Juka Bogman. Now it's time to recognize the speakers of this session. I'd like to invite the VP ISA, Dr. Abdullah Al-Falahi. Al-Falahi, عفوا. Dr. Abdullah Al-Falahi. Right. Mr. Wasim Ghadban. Mr. Philip Anthony Mark. Mr. Amjad Al-Khatir. Mr. Juka Borgman. Thank you very much indeed for the speaker and for Dr. Abdullah Al-Halafi. Now we'll have a lunch and prayer break for 1 hour. We'll be back at 1 p.m. So enjoy a break.
ضل الماوس يعلق لما اشغل هذا بيعلق الماوس بضل
الله يعطيك دكتور. Sure. You can go and start. Great. We'll call people. Thank you, sir. Good afternoon, everyone. I hope you enjoyed your break, lunch break. Right, moving forward with our journey. Before we start, a gentle reminder, please make sure that your phones are on silent mode. In case of emergency, please evacuate through the nearest exit or fire escape, which are marked with the green light. We have 2 on the sides and 1 on the back. With that being said, I'd like to call upon our next speaker. Our next speaker is Mr. Majid Rifai. Mr. Majid is CEO at Desert Technologies Industry, and his presentation is going to be about digital technologies made in Saudi Arabia, supporting net zero emissions. Please help me welcome Mr. Majid Rifai.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. First of all, just before we start, I would like to congratulate Kingdom of Saudi Arabia for the announcement of the new strategy of industrialization, which is announced by the custodian of Tutu Holy Mosque day before yesterday. Inshallah, Ya Rab, with this vision and what we are doing right now in the renewable energy, it will be a huge added value for us in order to improve our capability in the kingdom and to show that the renewable energy part, it's one of the important parts from the mission of the kingdom, inshallah, in the near future. شغالة ولا لا؟ Okay, I will try to be more focused because usually after the lunch, people, they will feel relaxed. People, they will feel that they need to be little bit sleep. I will try to be more attractive. I need full interaction from your side. And please interrupt me whenever there is any questions to proceed for. Bismillah. Let's start about our company as a Desert Technology. Desert Technology Company, we are a group from 3 companies. An industrial company which is focusing in manufacturing part for the PV model in Saudi Arabia. And the other company, it is, okay. The other company, it's an investment company which is focusing in development and EPC part for the full renewable cycle. Let's talk about today, we will focus about our industrial arm. In DT Labs, or we call it DT manufacturing, our value proposition is to manufacture a full PV panel solution based in Saudi Arabia in the kingdom with a capacity of 300 megawatt plus. Our factory is located in Jeddah, and we are focusing more than 50% of our supply to international markets, and the remaining it's for the local market. And this is, it's a quick snapshot. We are offering in manufacturing part a different type of solar panels, starting from the solar panel from the 320 watt up to 550 watt with the container solution for the rural areas and off-grid systems. And it's a quick glance pictures about our manufacturing facility. I will skip it. Our production line capacity, it started with 15 process. The first process, it's with the stringer, and it will end with the packaging. I will take you a tour in the process, which each and every process, what we are doing in it. With the stringer part, we are the first Saudi manufacturing who built a stringer part and a full capacity solutions of manufacturing arm in the kingdom. The factory, it was established in 2019, and the factory right now processing in different type of scale. We are honored to announce that we, alhamdulillah rabbil alameen, we supply to Germany, we supply to Spain, we supply to Greece as a Saudi-made product. And it's already available there in rooftops in Frankfurt, Berlin, and Hamburg, and Madrid as well. Usually, the quality part, it's an important arm to be considered in any part of industry, especially in solar PV part. In solar PV part, we already aligned with 3 different labs, 2 internationally and 1 local. We aligned with TUV in Europe, in Netherlands especially. We aligned with UL from United States, and we are aligned with the GCC lab nearby here in Dammam. So all our product, it's officially certified from one of the 3 labs. And the good things, GCC lab, it's already aligned with UL. So whenever we do any certifications with UL lab or GCC lab, it will be considered as a 1 arm. Rest of the material, for sure, it's an ISO part. And right now we are in process to get it certified from SASO. As SASO, it's fully depending on UL or TUV. The process of the manufacturing, as you can see here in the picture, we have more than 20 items to be assembled in the kingdom. Out of those 20 items, 20% of them, it's fully localized in the kingdom. We are buying them from a local market. And this is another project, or another product, this is related to the rural areas for off-grid systems. We use this especially for, like 2 years ago, it's happened the first rally in the kingdom for Dakar. We supplied the full power with this container solution, which is supported by a 40-feet container with a 72 kilowatt, the maximum one, and there is a 20-feet container. It can support up to 32 kilowatt. And this one, right now, it's supplied also to NEOM, to Al Qaddiya, and to Red Sea project. Let's focusing about localization. What is make us different from others? Why we need, we are building capabilities in our own self to assure that we reach to a target for localization. Usually, our localization enables us at focusing into different parts. The first one, it's a government support. There is a lot of government initiatives supporting from Saudi, from SIDF, either from Hadaf program for manpower support. So many initiatives. Once we applied the full localization program, we are having a full support from them, either in funding-wise or in support of expansion in the future. Financing. There is a lot of financing programs also supported from the government. Material in kind by increasing the value chain in the kingdom. Like simple examples. We are in desert technology. If I buy some materials from X company in the kingdom, either it's located in Dammam or Riyadh or Jizan, I will add the local value of the product in the kingdom-wise. So I will assure by end of the day I have a high value proposition in the kingdom from in-kind material. The capability building transfer know-how. It will open a channel for technology transfer. That's any new entrepreneur who would like to enter to such businesses in the future, we will be more than happy to support him in order to build his capability either in renewable energy part or in net zero carbon credit in the future, inshallah. The last thing, it's regulation, in order to be aligned with such regulations in general. We are, as of today, the first Saudi panel manufacturer in the kingdom who have a certification of Saudi made. Alhamdulillah, we get certified for this product almost like 6 months ago. And this one, it's give us a privilege among others for exporting our material to the countries I mentioned a while ago, plus to give me ahead of others in either in availability-wise, mapping of distribution of our product in more wide area in the world, inshallah. And this is where we are available as of today. I will start from west side to east side. Our product, it's available in the United States of America. Our product, it's available in Latin America and near to Antigua, to African continent, to Iraq, Europe, and soon, inshallah, ya Rab, we will be available in Philippines and Vietnam. بأمر الله تعالى يا رب. This is our local content value chain. How can we assure that our product is value added to others? We classified the mechanism of local content into 5 pillars, starting from the design. Okay, it's a simple calculation. Once you have your own R&D, that means you are owning the design 100%. If you get an affiliation with any international engineering house, that means the percentage of the engineering part from the pillar side, it will be decreased. We, in Desert Technology, we are owning it by 100%. It's our own design. We have no partnership with any either Chinese or South Korean companies or even European or United States one. We designed this panel and get it certified by a Saudi brain. Alhamdulillah Rabbil Alameen. The second part, it's the raw material side. The second pillar. The raw material side, as you know, right now, with the new missions and visions assigned or announced by the government, we will be able to localize as much as we can from the value chains we have in the kingdom. As of today, we are localizing only the frames, junction box, and the glass, and the EVA sheet. We are looking in the future to increase it to the wafer, to the cell, and even to aluminum frame, ribbon, flux, all the material. We can supply it easily in the kingdom, but it needs some time from others, which is help from the previous slide, as I mentioned here, the in-kind material. Why in-kind material? All the companies here in the kingdom, they're looking for an offtake agreement or for a continuous supply for their value chain. With the support we will have as a general, if we work together, we with others, we will assure this one, the material supply, it will be in high ranked. Right now it's 10% only, but inshallah, hopefully we are targeting to make it more than 50% in the near future. Let's go to the third pillar, which is the manufacturing arm. We own our facility and we are manufacturing our material by ourselves. So we ranked ourselves in this part into 100% part. The fourth one, it's the logistics. We signed an agreement with a local logistics company such as Bahri, such as Watan, to assure that the maximum localization from in-kingdom part to be in high ranked. Trying to avoid as much as we can the international companies, as we have like a vice versa companies who can support from the local market. The last one is the technical support. We are nearby. If anything's happened to our product, our factory, it's located in in Jeddah, and our technical team available in Riyadh and Jeddah. And soon, hopefully, inshallah, ya Rab, by mid of next year, we will open a branch here in Dammam. So we'll be available also for the eastern and northern area of Saudi Arabia, plus the other GCC countries as well. So we can rank ourselves in general. If you do a simple calculation, our localization, it's vary from 40 to 50% in general. Let's go about how can I link what we have a success from the renewable energy part with the Saudi Green Energy initiatives, which is announced by Sumu Sayyidi, His Royal Highness Prince Mohammed bin Salman in last October 2021. The links, it's easy. That's whatever hydrogen program we committed as a company to assure that we will run in support with the government initiatives, with the government program announced either from local banks or from the Ministry of Energy, to assure that whatever it's links together, and for sure with the cooperation and contribution done by all, it will be supported to us to do more بأمر الله تعالى يا رب. To make it success, there is 7 steps that have to be followed. The first one, it's a passive design optimization. Usually, if you would like to run any green energy program, you have to assure that whatever design it to be compatible with the needs requirement and for the future demand requirement. The second part, it's reduce operation energy to assure that whatever output I will have from this special program, it will give me the optimum output I'm looking for. The third one, it's elements and eliminate fuels to assure that I will use a clean energy part and to eliminate any non-green energy habits to be done. And it will be in sequence by providing the renewable energy part, limit output, till I reach to a full platform which is supported. Based on that, inshallah, with the full contribution part we will have, we are sure we will have a full green energy product with a local made product habit in Saudi Arabia. Thanks a lot. Appreciate your time. And I hope you are a little bit refreshed after the food. Thank you. Is there any questions or say you would like to answer before I will left?
We can take one question.
تفضل. So we are focusing right now into most likely in CNI part, which is commercial and industrial sector. The utility scale, still we are in line. Hopefully in the near future will be applicable to supply for the utility scale part. Inshallah. تفضل. No, as of today, it's in our pipeline. It will be inshallah in the near future. As of today, we don't have it. Is there any other questions?
That's it, sir. Yeah, thank you.
Assalamu alaikum.
Thank you very much. Thank you very much indeed, Mr. Majid. It's indeed a source of pride to see localized manufacturing in our region. So thank you very much for sharing this presentation. Our next speaker is Mr. Hassan Al-Tregi. Mr. Hassan is an engineer at Saudi Aramco. His presentation is going to be about digitalization of analog gauges scanning process. Please help me welcome Mr. Hassan Al-Tregi.
Assalamu alaikum everyone. Good morning, good afternoon. First of all, allow me to thank all the organization committee, Dr. Abdullah and all the organizers, as well as the sponsors for organizing this magnificent event and also for giving me the chance to speak today. My name is Hassan Al-Tregi. I am a research engineer in Saudi Aramco Research and Development Center. I work in the Oil and Gas Network Integrity Division. Our team is focusing into developing technologies that solve challenges for Saudi Aramco. And usually these technologies, they have development of IR 4.0 elements and components such as robotics, machine learning, computer vision, and such on. Historically, we have developed a few technologies that reached to the market, and some of them might be known to you. The first technology was Saudi Aramco inspection robot, SAIR, and other technologies such as swimmer, shallow water inspection and monitoring robot, It was in collaboration with Marine Department. Today I'm going to talk about analog gauge scanner and how its impact on reaching the goal of the company and the kingdom towards net zero. This project is actually in collaboration between PNCSD and KAUST, King Abdullah University, and as well as Yanbu NGL. So the agenda for today will go through the challenge, background, and then propose technical solution, and then go through the AI detection algorithm that we developed in collaboration with KAUST, and then show some results of the technology field testing that we performed in Yanbu NGL last month, and then go over the future plans. So the challenge is we have in Aramco like more than 30 Aramco industrial facilities, and many of them, many of them they have critical gauges that are recorded manually every day. We are estimating the number is more than 10,000 critical gauges, and they're recorded by operators through the operator rounds, manually recorded on pieces of papers 3 times per day. And then after the recording, they get archived in an archive manually as well. So you can assume that, or you can imagine that all of these data doesn't have any connectivity to any digital database. Also, we are losing a lot of opportunities here to integrate this to a digital platform where the data can be cross-validated with other digital data. And also for troubleshooting in future, all the data is recorded or saved in archive and in hard archives, and it's going to be like difficult to retrieve this data, especially for historical data. So currently the operators take pieces of papers, they have all the equipment that they need to record and record various types of equipment. Most of them are analog gauges, but also they record level indicators. They also record status of equipment, whether they're working okay, not okay, and all of that is kept on piece of paper. You can imagine here the opportunities that we can tap into, such as the consistency of the handwriting. These papers are prone to loss, as well as they consume a lot of papers. And then also there is the human bias into collecting these data, especially under extreme weather conditions. You can imagine that the different operators would have different perception and different prediction. And the other point here, which I mentioned, is the manual cross-validation. So many of these critical analog gauges, they're connected on the same line to digital transmitters that they're saved in DCS or PI or other digital systems. But the point here, these analog gauges, they can be cross-validated with the digital transmitter twins on the same line. But we're losing this opportunity because the analog gauges are not saved in any of the databases. And also, if we want to do the cross-validation manually, it's time-consuming, and we don't have any timestamp as well. Like the operator could take the data at 6 a.m., but that does not during one shift, right? So it's between 6 and 3, and we cannot, when we compare the data that's collected to the digital transmitter, we are not sure at what time this data was recorded. Also, the manual archive is only saved for 3 months, it's time consuming to go through these manual archives and as well as subject to loss. So the business drivers for this project is to enhance the process efficiency, increase the reliability of data, and of course we have the environmental impact of reducing paper consumption. But what I want to focus on here is the early fault detection, which we are hoping to exploit and explore during our testing phase and our deployment. As I mentioned, like these analog gauges, they can be cross-validated with the digital transmitter twins, and this will give us like a new perspective or a new window to compare different sensors, values of different sensors. Especially the analog gauges are located at the physical location of the equipment, and they're the closest sensors to the to the equipment. So they're like what we believe is, since they're located at the location of the equipment, and there isn't any conversion between analog to digital or any transmission issues, like they would be the absolute values. So here I'm just recapping that the business drivers is process efficiency, digital transformation, enabling digital transformation here, as well as once we digitalize these analog gauges into digital digital platforms, we will be able to integrate this data with multiple other platforms such as SPI, such as mobility platform and others. Also, once we have these data on the digital world, we can perform data analytics, and this, as I mentioned, will be explored and exploited in the future. And we're hoping that with the data analytics, we will be able to predict whether there is going to be in the future any mismatches between the analog gauges and the digital transmitters that are located in the same location. So the technical solution that we proposed at the beginning of this project is to develop an AI-based mobile application installed on the industrial tablets that are approved by Aramco, to enhance the efficiency and enable digitalization of the analog gauges recording process. So we will be enabling the operator with a tablet. It's an industrial approved tablet that uses the camera to automatically digitize analog gauges located in the field. And then these data will be saved in a remote server, where this remote server can publish it and push it towards other platforms and databases. So the tablet, so the main components is the tablet. It has like a mobile application, Android mobile application, equipped with the AI algorithm that runs on Torch script, and of course the camera API that has all the features for the operator to take the image of the analog gauge, as well as a local database. And then this tablet, once the data is collected, it will be connected to a remote server and synced to the server. It will also publish this data to a dashboard. We have also a front end to the database to change some of the parameters of this system. The publishing here, we also developed the dashboard for the supervisors and foremans and the management to visualize the data that were collected by the operators. Also, for the current time, we are enabling the operators to print these data that they collected, because as of right now, we're only testing this in one unit in Yambo NGL, and Yambo NGL is still keeping the old process, which is keeping all the records in a manual archive or a hard archive. So that's why we're giving them the opportunity to print the data that were collected. In the future, we would like to do the integration of the system online, and we're hoping that we won't be needing to print any of these data, and everything will be stored on the cloud, on a local Pi or on the corporate Pi. However, right now I'm going to focus on the AI algorithm, which is our IP that we developed in Aramco in collaboration with KAUST. So how did we develop this? The issue with that we found in the gauges is there are so many varieties and conditions that we have to take care of, from lighting conditions, from different hard conditions of these gauges. And the solution to that was to simulate these in Blender. And we were able to create all of these scenarios in 3D simulated images that we use to train our machine learning model. By variating the time, variating the needle shape, adding lights, adding shadows, as well as we have also the segmentation of all the pixels in the image. So yeah, this is just a repetition. Okay, this is the image segmentation. Each pixel belongs to a specific class, whether it's a background or the gauge or the needle. And also the labeling is fit to our training model. And our algorithm is composed of two networks. The first network is called segmentation network, where it gives the class of each pixel. And the second network is called classification network, where we feed the input, the segmentation result image, as well as the original image to the network, and it should give us the locations or the angles of the needle, the start and end. We developed also a lab setup in order to test our algorithm. It was mounted on a small robot. The camera was mounted on a small robotic arm, and the gauge is mounted on a servo, on two servo motors, where the needle changes and also the orientation of the gauge change. And these are the number of images that we used. The model accuracy was around 90% for these samples. This is the Android app that we developed. I don't think I have the time to show it all, but I have the tablet with me in case anyone is interested to know more about the technology. I don't think I will be able to, yeah, I think the time remaining is less than this. But basically, the operator will select the unit and the area that they're going to read, and the list of equipment will show. And here, if it's a gauge, it will open a camera for the operator. And after some time, right now it's around 2 seconds. We're trying to minimize the time of the prediction. As you can see here, it's around 196. The operator will have the option to submit or to edit this value if it's outside the acceptable range. And we have multiple types of equipment. So, for example, if the equipment is off, the operator can just say it's off, and that will be taken as a record. These are for digital transmitters. As I mentioned, there are so many other types. This is for a level indicator. Yeah, we're allowing the operator to take this reading. This is just the dashboard that we developed for the foremen and for the supervisors to see the previous results or the collected results. And this is to show you the PDF that's generated. Of course, it's not filled with data, but yeah, this shows the concept. Here, the results of the field testing. I'm just gonna show some images just to for the talk. This image, for example, was perfectly classified. This is within 1%. If you're wondering where to look at, it's around here. Sorry, it's the areas that are in the red boxes. This is correctly classified difficult images. Like some of them are even hard for the operator to read, and surprisingly, the algorithm was able to detect them very accurately. These are some also of the hard images, but unfortunately they were outside our acceptance area, which is within 2%. So you can see the range error above in the corner. Most of them is between 2 and 3, but they're not far away from being correct, which is great. And this is the field testing results that we conducted in Yambo NGL. So the model was given to Yambo NGL for the past 4 weeks, and the testing will continue for the next 2 weeks until we go to the next stage, basically. So these are the initial results. We have around 93% within 2%, and also 95% of the gauges were correctly read within 2%. This is the future plan of the project. So at November, we're going to go through the research and development gate 5, which is basically to go into the, after that we'll go into the commercialization. And it summarizes the testing and validation in Yambo NGL that we have been performing in the past few weeks. And hopefully by next year, we will complete the online integration by the support of our partners from PNCSD. We're hoping that we can integrate or incorporate this AI algorithm to one of the platforms that they're, or one of the systems that they're deploying. This actually, this project started back in December 2019. I see Abdullah is laughing. This started from an idea that was that won the hackathon, first digital hackathon organized by YLab and PNCSD. We were lucky to win the first prize. This was the hackathon was conducted in the IR 4.0 for IRR Center in Midra. And I would like to thank all the teams that participated in this project, and we're looking forward to inshallah successful deployment and also successful exploitation and exploration of the values of this technology, as I mentioned, by comparing, by allowing this analog gauge readings to be accessible in the digital. We can compare and do cross-validation with different sensors in the plant. Thank you very much.
Thank you very much indeed, Mr. Hassan. Our next speaker is Mr. Shakur Ahmed. Mr. Shakur is a sales specialist at Al-Multaqa United Company. Al-Mutlaq United Company. His presentation is going to be about digital twin reduces the environmental impact of a production facility during its life cycle. Please help me welcome Mr. Shakur Ahmed.
Good afternoon, everybody. Ahlan wa sahlan. Yesterday I learned. Okay, I would like to introduce Karimana, director from Cadmatic, who has the biggest share in my presentation. And I also ask him to join in my presentation, please. Audible? Sorry if it is not audible. Okay. Thanks for those who organized, sponsored, and exhibited at this conference. Okay. So it's my pleasure to be here to deliver a speech on digital twin reduces the environmental impact of a production facility during its life cycle. So before getting into the topic, I think people here explained much about digital twin. Here we are going to take a look at why it is needed and how it will benefit us in terms of not only saving the cost and time, but also reducing emissions. So I would like to ask you a question, ladies and gentlemen. Do you think getting greener is expensive? I think at the end of the slide I will tell you the answer. So this is a report from International Energy Association, a report from United Nations Environmental Program showing that the building and construction industries is accounted for 36% of global energy consumption and 38% of carbon dioxide emissions. Not only that, 11% of carbon dioxide emission is from manufacturing, building materials, and their supporting products. So, as you know, the major source for building and construction industries is electricity. More than 19% it is increased since 2010. So, obviously, we know the electricity is generated mainly, the major source is from coal and natural gas. So, yeah, whenever I'm seeing the interviews from Aramco delegates, they are always telling Plan A and Plan B. Plan A to reduce the, to have alternate energy, which Majid Rifai, who did on-grid, off-grid solutions. So here is our solution, Plan B, reducing the emission in industrial plants. So we need to find where digital twin can impact. The World Business Council for Sustainable Development calls industries to have a whole life cycle carbon assessment and also set targets to decarbonize in their sectors. So it is essential to follow it and minimize the wastes, utilize the materials and sources properly in order to reduce the errors, reduce the emissions. So here, I think the round circle itself shows where digital twin can impact. So using digital twin solution, you can efficiently use the sources, manages the materials, and also reduces the emissions, reduces the energy excess consumptions. So before getting into the industrial plant, we need to understand the production asset investment life cycle. So, you know, the average lifespan of industrial plants is nearly 50 to 60 years. And in terms of construction project itself, 2 to 3 years. So as you see, the investment is high on the cycle. So connection to the emission will also be high. So we need to adopt emission reductant manufacturing technologies and perfect project management solutions in order to execute the project efficiently. In terms of operations, we need to adopt perfect asset performance management solutions in order to execute the operations, optimize the operations for reducing emissions. So digital twin is the solution, supports you enabling efficient execution of project and also in operations, safe and optimal asset operations. In this way, we reduce the emissions along the life cycle. So the creation of digital twin, initially the engineering department produces large amount of data during the investment life cycle. So if you see, the data will be added, procurement, construction, as well as the operations. So at Cadmatic, we understand the data has immense value. Data in a digital twin data, you can minimize the errors, minimize the double works, maximize the productivity, and using our Cadmatic solution, you may feel empowered with the project execution and operations. Digital plant life cycle will be achieved based on digital twin solutions, which integrates with the system used along with the 3D model. So the data drives connects the entire process where manual data handling is minimized. So improving efficiency. So based on our projects, we figure out nearly 23% of piping is needed for plant construction. This is some of the example showing that how we can reduce the plant excess material usage. For example, using the changes, using the materials in changes simultaneously with the design and construction, you can improve the quality in short time. Not only 15%, it also goes beyond that limit, 20%, based on your digital maturity and capabilities to perform better in executing projects. This calculation, I think, shows you potential reduction in a plant investment project. For example, 100 ton of steel piping, while manufacturing the 100 ton of steel piping, it emits 200 ton of carbon dioxides. So if you reduce the excess material usage and also material used for changes, nearly 10%, so nearly 40 ton of carbon dioxide will be reduced. So the project efficiency and emissions go hand in hand. So the term efficiency can be defined as ability to achieve an end goal with little and no waste, effort or energy. So using the things, for example, energy efficiently, with achieving the high quality with no errors, no excess materials, better project management, you can see the positive impacts in resulting emissions. So the digital revolutions, process industries across the globe are undergoing digital revolution, that is either creating or transferring business models. So they are actively embracing the immense possibilities offered by advanced digitalization. Digital revolution can be achieved via data-driven engineering. In a data-driven project, the digital data streams to be consistent, reliable, reusable across the life cycle of the project. So this is our platform eShare, which integrates all the systems used in your project as well as the operations into a single window along a 3D model. I will call Mr. Kari to tell more about eShare. He has a better experience and he is an encyclopedia for Cadmatic.
Thank you very much, Sukur. And is this really the first duo presentation we have on stand? I guess that yes. So, as how we understand digital twin by default, it is virtual presentation of physical assets. But as we well know that the information of assets are laying on really different systems. I guess that somebody said yesterday that Saudi Aramco has something like 60 operational systems. And the last one concerning reading the cages and having the information on field is another one. So what we have developed is this kind of system that actually enables to connect all this data to one window. And that actually is giving the possibility to smoothen all the operations, less energy used, quicker changes, and so on. So it really has an impact to reducing emissions. So I don't go further of these, but just to get you an idea that how this works. And if you have by chance visit our stand there, we might talk a little bit longer on this topic. So, Sukur, do you have any extra slides there?
So this is our Cadmatic integrated product portfolio. All our solutions are data-driven, online, concurrent, multi-user. So if you look at P&I, it drives the next detailed design phase of 3D model. And E&I, it's also comprehensive data-based solutions. All our solutions are data-driven for achieving data-driven projects. So I think by making construction projects better and more efficient will never conflict with achieving zero emissions. Rather, it will be the consequence of well-executed projects. I think getting greener does not cost more, but also saving cost and time. So Al-Mutlaq United is here uniting you with technology, feel empowered with Cadmatic. Thank you.
So, dear audience, do you have good or even better questions for us? I think that we have 2 of them left. Please. Sukur, it seems that we have done a good work. No one hasn't any questions. Okay, there is one hand up.
Thank you very much, Carrie and Sukur. It was a very good presentation. What I'm already a user for Aviva, so the technology which you have shown a benefit at the capex level for 15%, and major contribution is coming at the engineering stage because you presented something on saving on steel cost actually. But what in case if it is a brownfield where we already have the assets installed? So how your technology in that case is helping out in reducing the carbon emissions?
Thank you very much for an actually excellent question. So in the same way as we have greenfield projects where we have everything, let's say, done already from the beginning in digital way. So if we have brownfield projects, we have technologies to something like laser scanning, to actually speeding up the creation of a digital 3D model as it is from engineering model, and use it in the same manner than if it would be a greenfield project. So there are some extra steps or additional steps concerning converting the point clouds and this kind of data into some intelligent models, but the actual results and outcome is the same. I hope that this answered to your questions. So I actually use this opportunity to thank you very much for the organizations and sponsors for organizing this wonderful event. Thank you very much in behalf of Al-Mutlaq and Cadmatic.
Thank you very much indeed, gentlemen, Mr. Curry and Mr. Shakur. Our next speaker is Mr. Sridhar Reddy Mikala. Mr. Sridhar is pre-sales manager at Hexagon. His presentation is going to be about smart digital reality. Please help me welcome Mr. Sridhar Reddy Mikala.
Good afternoon all. Today I'm going to present how digitalization will help how to efficiently use the material and reduce the emissions during project and construction phases, and also during the operation and maintenance. Before I delve into the details, I would like to start my session with some data. So if you see, we have unprecedented growth in terms of GDP and population. But if you see, look into the details, we spend very little time on the planet Earth, but we consume most of the resources, which is not sustainable. So our aim is to make it sustainable, our planet, by reducing emissions and reducing the waste. So another data point I would like to present here. Today, we already, for the increasing demand, for the energy demand, currently we are using 1.79 Earth already. If you continue like this, we need 2 Earths by 2030, which is not sustainable again, right? So what I mean here is, if you look into the this chart here, it's very interesting. Last a billion years, if you look into the CO2 emissions, the emissions were always in the range of 200 and 220. But the most worrying sign is that abnormal hike in the CO2 emissions around last 70 years, which is a worry point. Let's have a closer look into this, the spike, that hockey stick. If you see starting from the industry revolution, and if you consider the duration from 1700s, mid 1700s to late 1990s, and last 30 years or so, we emitted more than 50% of the emissions. So, which is really worry point. What we can do for this? So, let's have a look how we can improve this. So, if in a simplified form, if you extract 100 resources from the earth, currently, if you do the things right, we are only consuming 60% of them. Because of the man-made mistakes, we are wasting 40%, and because of inefficiency in the recycling, so we are like not able to recycling properly the consumer resources. If you efficiently avoid the mistakes and do the things right, so we can avoid these waste resources of 40, and then if you recycle, the study says from the the consumer resources, if you recycle them, we can at least 50% we can reuse for the fresh production. So that way, in total, we are reducing 70%. So we only need to extract 30% from the earth. That's a huge reduction. So how we can do this? Let's have a look into circular economy. This is how it looks, the circular economy. We spend a lot of time during the design and of this product, and during the life of the, let's take a car as an example. And during the life also we spend a good amount of time of car, but post-life we'll spend very little time. What I mean is, if you recycle properly by separating iron, steel into iron, its bucket, and aluminum in its own bucket, and so on, so that we can efficiently recycle the item. This is around 30% of usage if you recycle the items. Let's spend a little time on the bigger part, which is the human mistakes. Look into this. So that's, if you see that the truck got stuck under the bridge, which is wasting a lot of resources. The truck is wasted, bridge is wasted, and it's supposed to deliver some items, and those items are not reached on time. So these are the mistakes that we need to avoid. But okay. So how we can do this? What we need to eliminate the human mistakes, and how to increase the efficiency during industry facilities. We need something called smart digital reality. Smart digital reality is a replica of the physical world, the physical object. It could be anything. You can apply the smart digital reality to any object in the real world. That will help you to improve the efficiency. For example, the core competencies in the smart digital reality, reality capture technologies, to digital capture of the physical world, positioning technologies that enables location tracking, navigation, and control of anything from anywhere. And design and simulation technologies enable design and replication of real-world scenarios. And location intelligence technologies enable active georeference intelligence of real-world situations. And autonomous technologies enable autonomy of any automation of any task, workflow, mission, or decision, that enabling the industries more towards autonomous industries. So once we have this digital, smart digital reality, let's take our example, how we can avoid this mistake. if you have a proper smart digital reality, the perfect replica of physical asset. If you assume we could have loaded the truck a day before, and onto the autonomous truck, because this already synchronized with the physical world, and we loaded the maps from destination A to destination B. That way, we are avoiding the mistake by using the smart digital reality. The smart digital reality can be applied for anything, like I said. So how we, as from technology provider, how we are empowering for the smart digital reality? I would like to delve a little bit more into the industry facilities during construction and project execution and operations and maintenance. Here at Hexagon, we focus on key 4 pillars, that is data. So data, whatever we do today in Hexagon, we all do around the data to better utilize the data that is being collected from different phases of the asset life cycle. And we understand that each company has its own way of digitalizing. They have its own their business properties, challenges. We at Hexagon, we help companies to transform their facilities into digital world, and we travel through their digital transformation journey. And we apply the automation on the work processes to make autonomous industry facilities to have a more sustainable planet. So the smart digital reality is not just a virtual representation of the physical world, but it is collecting the data from using the sensors, whether it is a brownfield facility or it is a new facility. So we collect the data, whether it is 1D drawings, 2D data, 3D model, and we contextualize the data by connecting the data from different other sources. And we give the intelligence by overlaying these data onto the several work processes during the plant asset life cycle. Let's find out the key components of smart digital reality. Digital projects and digital assets. Digital projects, if you see, we have 7 key work processes under digital projects: plan, design, execute. And we have, this simplifies the project execution, and this same is applicable for digital assets as well: operation, maintenance, secure. So this way, these combined, they're simplifying the phases of asset life cycle. The data is flowing across from different stages, and that is, we are improving the efficiency of these work processes. The digital backbone, the key component, it is collecting the data from different other sources and consolidating and contextualizing the data, and and overlaying this data on the work processes under digital projects and digital assets. Once the digital base is set up, then we can use technologies from Hexagon or any other commercially available products to enable more autonomy decisions by using connected worker, AI and ML models, or robots, etc. Let's now look into this. So once this smart digital reality is set up for the end user, so there are many things happening behind the scenes. Through the digital backbone, the information is presented through the role-based single pane of glass by overlaying the data onto the work processes during plan, design, execute, and operate, maintain, and secure, so that for the end user, he can take a better decision. You don't need to worry and look into different other systems to find the information what is needed for his decision making in daily job. What I mean here is, if it's a plant manager, he can see the information through the single pane of glass what are the risks that are happening in the plant, the sensors that can produce the data, and that will be consolidated and presented through the single pane of glass. And same for maintenance director, you can see what are the equipments that are due for maintenance, whether the maintenance is happening as per the plan or not, to check the preventive maintenance. Also using AI ML algorithms, we can do the predictive maintenance to safe running of the plant. As a construction planner, you can check whether is fabrication and construction is in as per the plan or not. So this way, the single pane of glass help him to look into the for each and every user in the plant operations or during construction phase or maintenance phase, they can take a better decision basically. So have a AVI, how this single pane of glass works. So today I am acting as a unit superintendent. Here I can look into, through the single pane of glass, I can look all the work orders that is coming from plant maintenance system and logbook entries coming from any operation management system. And I can look into the health of my equipments in the plant coming from a integrity management system such as Senesco, etc. Now I can also monitor the production throughput. I can look into what are the list of actions that are pending. For example, I'm looking here a critical equipment where I can look that particular equipment inside the 3D model and see what are the required information. For example, if I want to check any design information, I can look into that. From the vessel tag that we directly jumped into the 3D model and it's highlighted, now I can look into the design attributes and can also look into the other details, the data coming from different other systems like a data historian. Now those can be adjusted and look within the range of 1 hour, 1 week, or 8 hours. And but that particular tag level, we are seeing what are the open change requests. So that way it is giving full picture what's happening in the plant. Now, so we can also overlay that information coming from Senesco for any integrity management system. We can see the corrosion loops and we can highlight them into a different color for better visualization. So we can also, this way we can run the 4D, 5D visualization, bringing information from other systems like construction management or any cost management system. The data need not to be inside the one single system, but this digital twin can bring the information from different other systems during the different phases of project life cycle and overlay on top of the 3D model. And this also helps by sitting in the office. I can, suppose if there is a maintenance activity that need to be performed, I would like to check whether the crane can pass through or not. I can make a measurements using 3D model to check what is the distance between those filters, for example. And I can go back to that one tag. From here, I will jump into another area. For example, I would like to look into the 2D drawings related to this vessel. So I'll select the tag and then jump into the 2D drawing. It automatically highlight where all this tag appears inside all the documentation. So I selected a process engineering flow scheme, which is highlighted, and I can look into other tags within that process engineering flow scheme, and I can look the same details that I was looking at the vessel tag. So I can see all the open work orders again coming from plant maintenance system. Suppose if you have all the 3D model available for the greenfield, that's fine, but we can also consume the digitalized the brownfield data, like I said, using laser scanning. So the laser scan can be viewed within the single pane of glass, and that will bring me like from this tag I can jump into the info map, which is again from the single view you can see what are all the related objects within the plant. So that's a quick AVI, how a single pane of glass help for the end user. Could be a plant engineer, maintenance director, or a construction planner. So here, like I mentioned, so we have two groups, the digital projects and digital assets, which can help to digitalize the work processes during the two different phases. So here, and digital assets, we have also the different stages that you see: operational excellence, process safety, and workforce competency, and we have different solutions to cover all these stages in digital assets as well. So yeah, with this I would like to conclude the session. Thank you for the opportunity. Any questions, please? Yeah.
Hi there, nice presentation. I would like to ask you, from point cloud data to this digital twin solution which you have just shown, how much time it will consume to create a single pane of glass like this?
Okay, so we have in our Hexagon, we have a sister company called Leica. We have scanners, one of the world's fastest scanner, that can scan the 3D model, the physical plant, and we can load that into the digital twin. But the challenge is to geotagging. If you have some 2D documentation, we have algorithms based on the topology. It can identify the tags within the laser scan based on the drawings, for example, process engineering flow scheme, and it can geotag automatically, so that you will have the navigation that I shown to you.
Is there a limitation of that? For example, maximum 1 TB or 2 TB of data can be in time?
No, we have tools that can make the light, the scanning that is done through the laser scan, and we can display that over the zero footprint client without having any local any installation on the client machine. So this is not an issue.
One last question. From the raw scan, if we want to remove some unwanted equipments, or if there is, for example, a vehicle or something which we don't need, do you have any software which can do it?
Yeah, I'm not an expert on that side, but I can definitely check that and get back to you on this. I'm not sure if once the scan is done, whether we can remove some object from the scan or not. I don't know exactly, but I can get in touch with you on that point.
Okay, thank you.
Thank you.
Thank you very much. Oops. Thank you very much, Mrs. Rida. Now I'd like to call the speakers for the recognition of the speakers of this session. I would like to invite the Vice President of ISA to the stage. Mr. Majid Rifai. Mr. Majid, I don't see him. So, Mr. Hassan Al-Tregi. Mr. Sridhar Reddy Mikala. Mr. Shakur Ahmed and Mr. Karim Manar. I also would like to invite Mutlag United Company Group to take a group photo. Yes. Yes. Yeah, Mr. Majid Rafai, please.
We are really proud of Made in Saudi Arabia. It has been highlighted in my opening remarks. And, as a key message from the conferences like this. So we appreciate whatever you are doing and the contributions that you have done in this domain. It really relates to the conference theme and within the net zero and within the localization. So you got it all together.
This is the start for us, and we wish, inshallah, ya Rab, to have it 100% localized between the people.
Thank you very much. And more than this, they went even beyond the borders. So that's really appreciated. Wish you good luck and thank you
Right, thank you, everyone. Pleasure. Now we'll have a break. So yeah, I've got extra time there. We'll be back at 3 p.m. for the last session. So see you at 3 p.m. Yes. Right, ladies and gentlemen, there's been an amendment in the break time. So we'll be back at 2:35. 2:35. So at 2:35, we'll resume the rest of the speaking sessions. Okay, ladies and gentlemen, welcome back. Hope you enjoyed your break. Right, let's continue with our last speaking session. Our next speaker is Mr. Rick West. Sorry, Mr. Rick West. Mr. Rick is Vice President Global Engineering at Kilapon Engineering. His presentation is going to be about IoT in the process industry. Please help me welcome Mr. Rick West.
Take your time. Well, I don't think I'm going to have it. Okay, we'll work it out. Good afternoon, everybody. So once again, my name is Rick West. I'm the Vice President of Global Engineering for a company called Clip-On Engineering. For those that don't know, Clip-On Engineering is a division of the Weidmuller Group focused on the process industry. I am here today representing both Weidmuller globally and obviously our local operation, which is the Weidmuller Saudi Arabia facility. So, as an introduction, today I'll be talking about IoT in the process industry. Mostly as an introduction, as many would know, it's a very complicated topic and probably cannot be covered in a short period of time we have today. So in today's competitive business climate, process plant operators or owners are looking for new methods to quickly reduce costs, increase operational efficiencies, or comply with new regulatory requirements, whether they be safety or environmental. Whatever the desired outcome, addressing these challenges with traditional technologies can often yield undesirable results. These undesirable results are generally due to high implementation costs or operational disruption. With this in mind, many operations or operators are now considering IoT systems. But what should be considered when considering an IoT system? What are the challenges? What technology should you use within this landscape? Today, I'll introduce many topics that should be evaluated when considering deploying such a system. The first step is to identify areas of the plant or processes or equipment where savings can occur. In most cases, these plants have been neglected for many years due to the operational disadvantages of installing IoT or monitoring systems. The reasoning or rationale for installing a monitoring system can be different depending on the application in question. But focuses such as increased data collection, operational safety, compliance, regulatory or environmental, or predictive and preventative maintenance tend to steer and be presented as the most popular use cases today. When considering these use cases, it is pretty predominant in the industry now that most of the deployment opportunities for IoT systems are brownfield. When we refer to brownfield, what we mean is existing operations or areas of the plant that are either being upgraded or expanded. In either case, or any case, these systems have a common fundamental requirement that should be considered before deploying an IoT system. Today I'll cover 4 of these common areas. The first being IoT system and interconnection. The second being new data and collection and deployment. The third being IT system and interconnection, and data usage. 2 areas which are commonly focused on from an existing apparatus or installer or operation is obviously the interplay between OT and IT.
As we mentioned before, the likelihood is we'll be installing in brownfield environment. So due to the nature of a brownfield environment, it is a common requirement to interrogate or interface with existing control systems on a plant. This type of interrogation is commonly known as data mining. A term coined because obviously you are mining from data or collecting data from existing control systems and plants areas. An example of this would be interrogating an old mud bus system on, for example, an older area of an asset or operational area of the plant. And by installing newly introduced IoT master type devices such as a gateway or master interrogator, we can interrogate existing systems very, very simply without interrupting plant operations or compromising safety of existing control systems. But due to the extensive variations of connections deployed across all areas of the plant, this can be very, very difficult. It is important to select hardware vendors carefully to ensure they can support plant protocol requirements. Unified architectures such as OPC UA could and should always be considered as the platform increases and ensures an open platform for connectivity, interoperability and security. Providing a scalable method of data mining existing in systems when available. So as you can see on the screen here, this is a typical philosophy of what we call the system zone and the enterprise zone. So a common deployment of essentially OT to IT. And it can be very difficult to find where an IT or IoT system will fit in, which we'll talk about a little bit more when we get to IT infrastructure deployment. So new data collection, it's probably the most debated area about in IoT. So we all know now with IoT infrastructures there is an ability to install wireless sensing equipment to increase your data collection. It's considered quick, it's considered low cost. Most of these wireless sensors are generally battery powered but can be wired as well. And when we're considering battery powered systems, they can be brought online in a fraction of the time from a traditional sensor that requires wiring and configuration into the existing infrastructure. But depending on the application, requirement of such sensors can be a key choice, and the protocols associated need to be evaluated carefully. Today, or over the next few minutes, I'll introduce some of the protocols and technologies that can be deployed in association with either sensor deployment and or what we call node deployment, which is where the data is being collected to. So the first being Bluetooth or BLE. So for those that don't know, Bluetooth and BLE are, whilst they are similar, they are not identical. So Bluetooth is a short-range wireless technology. As we all know it, we use it with our phones every day. It uses ultra-high frequency and is relatively low power. But it does have limitations. Due to its ultra-high frequency, its transmissions distance is greatly reduced. And in general, Bluetooth in its traditional form is a reasonably power-hungry system in compared to its sister protocol being BLE. So BLE is obviously the Bluetooth low energy version of Bluetooth. It uses a similar wavelength and frequency, but because of its low energy coin, it is obviously reduced transmission length as well, so even further reduction on top of Bluetooth itself. So whilst it is an ideal deployment for IoT systems, it is important to consider your infrastructure requirement when considering using BLE. Do you have enough transmission distances? Do you need to have multiple gateways or repeaters? and or if you're in a situation where you've got a lot of variable speed drives or variable frequency drives, giving a lot of EMF, because of the ultra-high frequency associated with BLE or Bluetooth, it can disrupt the signal conditionally. Then we move to cellular. So cellular is probably one of the most widely available communication protocols we have. Obviously, everyone carries a cellular device in your pocket right now. I don't think there will be one person here that does not have it. Because of that, it is well suited to IoT applications. They can communicate over long distances. Networks can be established very quickly. And a high bandwidth can be created, up to even 5G. But because of its, generally because of its communication latency and requirements, it is a very power-hungry system. So it's important to, when considering cellular deployment, to also consider the fact of the communication devices you're looking to seek to connect to. Because some sensors or deployment apparatuses will not last the requirement based upon your polling rates and things like that. One of my personal favourites is the next one. So LoRa, or LoRaWAN. So LoRa is for what we call non-range, is a non-cellular wireless technology. And as I just said, it offers for long-range capability. It is very low power, similar to Bluetooth, and it supports secure M2M transmission. And for those that don't know what the M2M machine means, it's machine to machine, or device to device. The other advantages of LoRa and LoRaWAN systems, or LoRaWAN traditionally, is also you can deploy mesh networking systems to establish a robust ring topology to ensure when you deploy multiple sensors into the field, you can essentially ensure that there will be no breakdown in communication because of one device failure. So it is a very, very popular or emerging technology from a protocol standpoint to be used in association with wireless technology or IoT deployment. The next is MQTT. So MQTT, for those that don't know the term, is a publish or subscribe architecture. So publish and subscribe is also commonly known as a pub-sub network. It again enables machine-to-machine protocol, and how it works is a very simple messaging protocol that essentially works on a subscribe basis, meaning not all devices in the network need to see all data associated. So you can control the flow of information between various devices in the field. This ensures that your data bandwidth does not cause issues and you have no latency issues in the field. It is especially good for low bandwidth situations and is perfect for unreliable networks because of its pub-sub philosophy. Because again, one breakdown does not constitute the breakdown of the entire system. Other technologies such as Wi-Fi, again, a very, very commonly known type of communication protocol, is also frequently used. It's fast, it's reliable. There's multiple standards, multiple frequencies, multiple protocols that can be supported over Wi-Fi. But when we're talking and considering about IoT networks, especially on existing sites and infrastructures, you can have obviously issues of overcrowded bandwidths because we've got multiple devices communicating in existing sites. And also traditionally, because of the way Wi-Fi works, it is very power hungry. It usually requires that you will be looking to deploy hard or fixed wired systems to support the Wi-Fi network. You would not use Wi-Fi with battery systems because you'd be changing the battery every day. There is no rest and sleep options in Wi-Fi outside of a wake-up tone, meaning that deployment is not ideal unless you're going with wired apparatus, and also as long as you've got a site that is not highly utilising Wi-Fi technology. Because when you have multiple Wi-Fi networks, you will end up getting interference. The next one is Zigbee. So a lot of people may not have heard about Zigbee. Zigbee started as actually a home network mesh topology for building automation. It has now moved into industrial automation. So it had very humble beginnings and has now moved into the wider market. Again, like LoRaWAN, it is a mesh network topology. So meaning that you're not relying on one device to maintain communication, which makes it a variable, stable infrastructure deployment. Others like Z-Wave for wireless networking communication is also available. Again, Z-Wave is a mesh network as well. There are many, many others such as CoAP, LWM2M, but I will not talk about those today because we could be, as I said, be here forever. Okay, moving to IT system and interconnection. As an organisation that ever deploys an IoT system, IoT systems are obviously integrating into IT networks, so we have to be important to establish secure connections and also consider more modern cybersecurity requirements such as IEC 62443. It can be difficult to follow such guidelines and apply them to a working situation because no working situation is ever the same. But a practical approach should always be considered, and it's important to get experienced professionals to work together in a collaborative way to develop a methodology of deploying an IoT system. One of these areas is also considering cybersecurity protection. So on the right here, you'll see the 4 levels of cybersecurity from SL1 to SL2 and down to SL4. Majority of IoT infrastructure consists itself from SL3 down to SL1, SL1 being the field devices, SL2 being your data collection wireless gateways, and then SL3 being generally your access point to your main control system. It's important to assess your site carefully and your system carefully and deploy security requirements as necessary to support your IoT and cybersecurity requirements. Considering that there are multiple security elements that should and could be considered in association with IoT. First being what we call ACL or network access control, where you can actually deploy networking access control, user rights to even sensors out in the field. The next is TLS or SSL. For those maybe from an IT world would have been more familiar with TLS, which is what we call Transport Layer Security. SSL is the successor to that. It is a well-known internet security standard that you'll see on every one of your browsers today and can be deployed into an IoT system. And because of its high encryption, would take supercomputers hundreds of thousands of years to crack even one access right code between one device and another. So it's always a very, very popular methodology when deploying an IoT network. Other elements is DHCP or Dynamic Host Configuration Protocol. Again, Dynamic Host or DHCP is another very popular deployment methodology in existing IT networks, and now with common new technology from an IoT standpoint can now be deployed right down to the field into even the gateways collecting data. It is important to note that no single IT communication protection protocol is suitable for every application. Most applications myself have worked on over the years usually deploys multiple. A mixture of SSL, TLS, mixture of DHCP, or even port forwarding and port priority messaging and things like that. So it's important to understand it's never one topology you will use when deploying an IoT network. So finally, the final point will be data mining, or data usage, sorry. So data usage is all about gaining what you wanted to come out of derived of your system you're deployed. What did you want to get out of your system? This consists of three main areas. Pre-processing. It's important as we start collecting considerable amounts of data from the field that this data is pre-processed before moving data from A to B. This ensures that we prevent packet loss, we consolidate data, and we consolidate to one single point of truth, so if there is a communication breakdown, the data is not lost, and it is also consolidated and time-stamped. So it is very, very important, and most companies do not consider in the early stages of an IoT deployment how important data pre-processing it is, because it also prevents packet loss during your communication between A to B. You definitely don't want to be communicating raw data and having one or two packets lost, which means that you've lost that trending data on your existing system. The next is initializing and baselining data. As we talked about in our common use cases, whether it be environmental, safety or regulations, baselining data is really, really important, especially for systems that have not been monitored before. So it's very common that you will deploy an IoT system and use that system to monitor before you move into a predictive and preventative maintenance model, so you can learn what the industry or the application norm is before you start analysing. Sometimes you can use data scientists, sometimes you can use automated machine learning, but you do need to create a baseline. Otherwise, the benefits you are seeking will not yield anywhere close to the desired outcome. And it's a common mistake in the industry to think that you can deploy an IoT network and automatically see great yields of results without having that baseline data created. And finally, the desired outcome. As this step defines, it's where we basically get what we wanted out of the deployment of a system. It can be feeding an SCM, a supply chain management system, a quality system, an info record system. It depends on however you want to deploy it. It can be monitored by what we call set point deviation, meaning that we are only looking for change in data, or we can go all the way to an AML system. Whatever the importance of what you want to gain out of the system, it's important that the outcome is critically dependent on the other steps I've just talked about. If you do not address those other steps, you will not get what you want out of the system, which means it will not have the desired outcome, which is what in the early stages of IoT was seen, because it was not a known process or step to manage that process. Okay, so thank you very much.
Thank you very much indeed, Mr. Request. Our next speaker is Mr. Rich Cole, joining us virtually all the way from the UK. So let's...
No, if I'm honest. It goes up for sure, but it doesn't, it doesn't spike massively.
Yeah, we had enormous...
Unmute. Mr. Rich?
Performance driven. Oh, I think
we're on.
Here we go. Great. So our next speaker is Mr. Rich Cole. Mr. Rich is Global Lead for Digital Carbon at EY. His presentation is going to be about the role of professional services in digitalization towards net zero emissions. Please help me welcome Mr. Rich Cole.
Thank you very much. And first of all, may I just check that you can hear me?
Yes, we can, sir.
Very good. Ladies and gentlemen, it's my pleasure to be speaking with you all today alongside so many excellent speakers. As you heard, my name is Rich Coe, and I'm the global lead for EY's digital carbon solution. Over the next 15 minutes, I'm going to explain our view on the role professional services firms play in digitalization towards net zero. Evidence of climate change is everywhere. Extreme weather events are increasing in frequency, and whilst there are deniers, it's all but self-evident that the burning of fossil fuels is the root cause. Global temperatures have increased in near lockstep with the accumulation of carbon dioxide in the atmosphere. What is self-evident, though, is not necessarily self-correcting. The process that brought us to this place wasn't directly engineered by policymakers, and policymakers will be hard-pressed to influence, let alone dictate, a process to undo the damage. The habits of billions of disconnected consumers when it comes to buying and using energy can be bent but not broken. This will take time, and our advice is to use that time wisely. Companies like yours will need to respond to the multitude of forces that are accumulating, but in the end, you're in the business of providing energy to consumers. Even if policymakers could dictate an outcome, it isn't clear what outcome they would dictate. As always, events have taken over, and as often it happens, the urgent has taken priority over the important. Before February, the balance between energy security, energy affordability, and energy sustainability was easy to understand. Security and affordability were reasonably assured, and sustainability was the focal point. That balance was reflected in government policies, consumer attitudes, company strategies, and capital allocations. When the supply of gas to Europe came to be at risk, the priorities and potentially the path shifted abruptly, but the destination remains the same. Security and sustainability are both enhanced by investments in low carbon energy. Notwithstanding the short-term opportunity presented by gas scarcity, pressure remains on oil and gas companies to invest in low carbon alternatives. That pressure comes from three sources: tightening regulations, changing consumer attitudes, and the goals of capital providers. Governments are quick to set goals, but oftentimes slow to translate those goals into action, and action can be uneven from geography to geography. Carbon reduction targets will eventually be translated into law, but the form, the timing, and the magnitude of new regulations is unknown. We need to be ready for anything, and that means starting the decarbonisation process now. Ultimately, consumers will drive this process. Companies won't produce what consumers won't buy, and we're at the beginning of a trend that has the potential to lead people turning away from fossil fuels en masse. Again, the no-regret strategy has to be to decarbonise. In the here and now, the most immediate pressure comes from the capital markets. Investors are smart, and they will not make big commitments to sunset businesses. Companies across the sector are responding aggressively. Every oil and gas major and the biggest NOCs have committed to net zero targets on a Scope 1 and Scope 2 basis. Setting those targets is a no-regrets decision and an obvious way to satisfy governments, consumers, and investors. We know how to eliminate methane emissions and flaring. Implementation is a question of time and money. External pressures have mitigated whatever competitive reason companies had to avoid taking those actions. Everyone is dealing with the same environment. Scope 3 emissions are another matter. Eliminating them will require whole-scale restructuring of the business and redeployment of both capital and people on a scale that is unprecedented. When we look for industries that have undergone disruption as radical as what's on the horizon for hydrocarbons, we don't find many. That being said, if the world is going to meet its climate goals, Scope 3 targets must be set and must be met. So we're going to decarbonise. The most important question, which is still unanswered, is how, and how we do this at scale. Peter Drucker, who is one of the famous management consultants in our industry, once famously said that you cannot manage what you cannot measure. Carbon emissions are no exception to that principle, and the fact of the matter is that our industry is challenged to accurately measure what it emits today. let alone measure improvements on the return on decarbonisation investments. There are good reasons why this is the case. Wellheads and refineries are of course spread across the globe, oftentimes in remote locations. The amounts of data companies will need to gather and process are huge. The nature of the collection process makes it difficult to ensure data quality. The industry is global. The standards of measurement and reporting vary from country to country. Companies are organised to maximise the production of oil and gas, not minimise carbon emissions and carbon emission standards that weren't even contemplated when most of the systems and processes oil and gas companies use to look after their businesses were originally engineered. Digital technologies will be the most important enabler of the decarbonisation journey. Collecting, processing and reporting carbon emission data will be a licence to operate issue, requiring no small number of new systems and processes. Reducing operational emissions will be the first step in the decarbonisation journey, and real-time, highly granular data on where emissions are coming from will define the winners and losers of that race. Down the road, carbon credits will be the tradable output from decarbonisation investments, monetising the optionality in a portfolio that includes oil, gas, hydrogen, biofuels, along with carbon credits, is a significant opportunity for companies that have the right skills, the right culture, data and market awareness, and most importantly, technology. As we've heard from our other expert speakers, this is already happening and the results are impressive and promising. What's especially striking is the urgency with which large profitable companies are attacking this problem. We've heard many examples over the last couple of days, and across the sector, every oil and gas company is in action. A leading oil and gas organisation is partnering with Microsoft, as are many others, to develop an integrated cloud environment that collects real-time emissions data from the oil field to help the company better manage methane emissions. And the examples of the role digital and data will play in this journey are clear to see in the actions the sector is taking. When leaders lead, others will follow, and the leaders in our industry are already making the big moves in digital carbon. So what's the role of professional services in this equation? Professional services firms like ours have a critical part to play in the digital decarbonisation journey. It's no surprise that most solutions from the professional services sector are focused on emissions calculations. It's the most urgent need, where the type of capability we have in our sector is currently best pointed. It's a precursor to almost everything else a company might do when it comes to analysis or interventions. It has the most potential to dovetail with existing processes like financial reporting, and it probably doesn't require companies to make adjustments to long-standing successful operational processes. All of our competitors are in that business, as are a large number of IT consulting firms and technology companies. And where are we, as EY, differentiated? We've of course built our own capability within the emissions calculation space in line with where our peers are focused. But where we differentiate is our focus on using advanced analytics and decarbonisation expertise to drive insights and decision making. As we've heard from the speakers today, there are a multitude of different technologies that must play a role in decarbonising our sector. And what we're finding is that there's an increasing need to understand and draw insight from the many different transition pathways and technology options that are now available for us. Organisations like yours must make informed capital investment decisions on where to point resources that will have the best financial and carbon return on those investments. And these decisions must play out in a continually changing external environment. So the ability to dynamically model different pathways will be critical to accelerating the overall decarbonisation journey. Another critical part of this is then to be able to link decisions to action across the organisation. Ultimately, decarbonisation at the scale that our sector will drive is an end-to-end transformation for any organisation. Almost all parts of an organization have a role to play, and a big part of what we do is helping organizations to structure and execute these types of decarbonization transformations at scale. No single organization will be able to deliver decarbonization at scale. The scope of the problem is too large and the skill sets are too varied for one company to have all of the answers. At EY, we've established global alliances with some of the world's largest technology firms and are recognized as the preferred partner by these companies. At Microsoft, we've built a set of accelerators on Microsoft Cloud for Sustainability platform to help understand and evaluate different decarbonization interventions across an organization's supply chain. And in 2022, we won 7 of Microsoft's Partner of the Year awards. Similarly, at Enablon and SAP, we've been recognized by both organizations in our ability to partner and execute at scale wider ESG and sustainability solutions. We are focused on growing our alliances and continuing to develop new solutions to help clients across our sector to decarbonize at scale. And what we're seeing is a very symbiotic relationship. We require the capabilities that these organizations have in scale enterprise platforms. The tech firms require our decarbonization and transformation expertise, and it's this combination of capability that can help organizations like yours to decarbonize at scale. No one knows how the decarbonization journey will end. Everyone has a point of view about how much and how fast carbon emissions will need to decline. In fact, most analysts have more than one point of view. The one thing we know is that oil and gas companies will have to lead the way. The competencies and market reach necessary to bring about a rapid and complete transition to low carbon are found everywhere in today's oil and gas companies. Keeping those companies profitable and harnessing their strengths can only serve to hasten the development and commercialization of clean energy technologies. Thank you very much for the opportunity to speak to you all today.
Thank you very much indeed, Mr. Rich Coe, for your presentation. Oops. Clap again. Thank you very much indeed, Mr. Rich Coe, for your presentation. It's been a pleasure having you.
Thank you.
Okay, we'll leave the conference meeting now, sir. Thank you for your time.
Thank you.
Our next speaker is Mr. Bhargav Shah. Mr. Bhargav is the Chief of Staff at Tendered. His presentation is going to be about using AI to monitor and control emissions on projects. Please help me welcome Mr. Bhargav Shah.
Do you have a mic instead? Good afternoon, everyone. It's great to be here amongst you all. And my name is Bhargav Shah. I'm the Chief of Staff at Tendered. And today I'm going to talk about how to use artificial intelligence for efficient and sustainable fleet operations. When I said fleet, basically it covers anything like vehicles, heavy equipment, and even vessels which are offshore. And the goal is it comes in form of a project control center or even a mobile application or even the web browser. And it basically helps projects optimize fleet operations using artificial intelligence by getting actionable intelligence from the platform itself. And this yields minimizing wasted carbon emissions, increase fleet production while making sure you enforce safety policies as well. We've been recognized by various entities, regionally as well as globally, and naming us as the most innovative company in this space. And this is how we do it. We aggregate data in various forms and from multiple sources. You could do it in form of connecting devices and proprietary AI sensors that we connect to your fleet, and we fetch data from that. Other things that we do is connecting to your existing internal systems, let's say your ERP software or any other software, to fetch data from that. And the third one is connecting to your existing OEM data sources as well. So that does not require any hardware sensors. We combine all of these data points together and send it to Tender's AI system to process further. And that gets sent into two different dashboards, which is within the same platform, one of which is intelligent fleet management, and the second one is carbon monitoring system. Rather than tell you, why don't I show you? What we see here, to play the video. What we see on the left side is basically one of the deployments that we made using our AI vision sensors. These sensors are constantly computing the amount of earth moved by an excavator. And it's not just telling you the engine on hours, it's actual equipment-specific activity. So it collects a lot of information in raw data format, the bucket activity, the number of cycles, whether there is truck nearby or not, and also any other safety hazards if around. We run our AI neural net to compute how exactly productive these equipment are, run error detection algorithms, and then give you a final smoothened data all the way in the bottom, telling you whether your excavators are productive or not. And you can do apple-to-apple comparison to see which excavators are working really well versus which ones are not. Thinking about productivity is very important, but how do you make sure productivity is tied in with green operations? Before we jump into how we make our operations more green and sustainable, let's look at this chart, which is from an equipment's 1-year life cycle. The majority contributor here is the dark blue, and that is coming from energy consumption, which is fuel. And one of the first and the most important thing any fleet operator need to do is curbing down on the amount of fuel consumption from their fleet. And we do this by connecting to any type of equipment or vehicle, onshore or offshore. Let's say stationary equipment like generators, moving equipment like trucks or mobile cranes, even stationary and moving equipment like excavators which are doing earth moving activity, all the way to vessels that are offshore. We fetch data from engines, PLCs, and also do emission profiling from the machine itself. This combines data from the machine, the emissions profile, as well as the real-time utilization data, and projects how exactly your AI system is going to yield the final emission monitoring from it. This is very quick and easy to deploy and very cost effective because it doesn't require an actual emission sensor installed on it, which costs thousands of dollars. The final product is at a project level, what is the total carbon emission coming from different types of equipment that are present on the site, and exactly how many trees do you need to plant to go carbon neutral on your fleet operations. You're able to see the working versus the idling emissions as well, and gets more granular when you go next by looking at the equipment specific emissions as well. It's in form of reds and the greens, The red basically means that the equipment is switched on but idling. It's not really doing productive work. On the greens, what it basically means is it's a lot more productive and it's not wasted emissions. As we see right here, it's very easy to understand that the machine in the bottom is very much more versed towards idling versus being actually productive. So the opportunity is to reduce all of the reds and making it a green chart to make sure your wasted emissions are a lot lower than usual. So it's a three-step process. We connect different kinds of equipment, be it onshore or offshore. The first thing is start by monitoring the overall emissions using the emissions module. Once you know where do you stand today, the next step is to make sure using Tender's actionable insights module, you're able to get information like which equipment are not performing well, which ones are performing really well, and basically focusing on the ones that need care. And then the left ones is where you offset all of the rest of the carbon using the offset module. At that point, you go completely carbon neutral and a step forward towards net zero. This is one of the case studies that we did with Saudi Aramco on green operations. We deployed this technology along with Saudi Aramco on the Spark project. Just in a period of 4 months, we saw a reduction in 38% carbon from the fleet over there. And using this product, they were able to make better decisions and decisions a lot faster than doing it offline. There are many other case studies like this that we have done. I'll be very happy to share that with you as well if you're interested. Finally, productivity is very important. At the same time, making sure your production is really high, but your emissions are substantially low to make sure you're carbon neutral. Combining those together will lead to effective fleet operations with increased return over investment as well as a step forward towards going net zero. If you're interested in doing this for your own projects, for the fleet that you have, on the right side is my QR code on LinkedIn, and on the left is my direct contact. We also have a team here, would be love to speak with you in person after this presentation. Thank you so much.
Thank you very much indeed, Mr. Bargab Shah. Now it's time to recognize the speakers of our last session. I would like to invite the ISA VP to recognize the speakers. Mr. Rick West. Mr. Rick West. we'll probably post Mr. Rich Ko's trophy. Next, we have Mr. Bhargav Shah. I can see Tender team. Would you like to join for group photo?
Yes,
please. Sure, sir. That's it. Sure, sir. Thank you very much indeed, everyone. We came to the end of this session and the whole conference. It has been a pleasure conducting the last segment of this conference. I would like to congratulate the conference chairman, ISA Society, Saudi Arabia section, our sponsors, our exhibitors, our speakers, and all attendees and delegates. This wouldn't have been a success without your contribution. Congratulations on this exuberant event, and congratulations to all of us. It wouldn't have been a success without this collaborative effort. Thank you very much indeed. This is Abdurrahman Al-Hammadi signing off. Enjoy the rest of your day and have a nice weekend. The presentations and the photos will be on the website, so stay tuned in the website of the conference. Thank you. It's either today or tomorrow. تشبه واحد من الأصدقاء اسمه محمد التمار. معروف محمد التمار يا أخي كلمة عارفه. في التصوير هو شغلة زي كذا ولا؟ لا لا مهندس هو بس ما شاء الله فيك شبه من الوارث. كيف هم كل شيء تمام؟ ما قصرتوا بصراحة إبداع يعني. Thank you very much. Excellent job. I'm very proud of you. Are you sure? Or you want to